Welcome, and thank you for being here. Tonight, I want to share something with you that might change the way you think about your own mind and body forever. What if I told you that your thoughts could change your heart rate? That your beliefs could alter your immune system? That simply imagining movement could make you stronger? Or that a sugar pill could trigger the same brain chemicals as morphine? This isn't magic. This isn't pseudoscience. This is the astonishing frontier where neuroscience, psychology, and medicine collide, revealing that the line between mind and body is far more blurred than anyone ever imagined. Over the next few hours, we're going to explore 100 carefully researched discoveries about the mind-body connection. Each one will reveal something remarkable about the hidden powers you already possess. Powers that have been measured, tested, and confirmed in laboratories around the world. But before we begin, I have a small request. If you find value in what you're about to hear, please consider subscribing to the Serene Science channel. Your subscription helps this content reach more people who need a peaceful place to rest and learn. A like or a gentle comment also makes a real difference in helping the algorithm share these videos with others seeking calm. And if you enjoyed this ad-free, uninterrupted experience, know that your support through subscription is what makes it possible. But now, all of that can wait. Right now, there's nothing you need to do but relax. Let your body sink deeper into wherever you're resting. Feel the weight of your head against the pillow. Notice how your breathing has already begun to slow, just from listening to these words. Close your eyes if you haven't already. Let the outside world fade into the background, and allow yourself to drift as we explore the fascinating science of mind over matter. Let's begin. Fact 1. Your brain actively predicts reality. Before you experience it, your brain is not a passive receiver of information from the world around you. Instead, it operates more like a prediction machine, constantly generating sophisticated guesses about what is going to happen next based on everything you've learned throughout your entire life. These predictions are so powerful and so deeply embedded in how you process information that they can completely override the actual sensory data arriving from your eyes, ears, skin, and other senses. Consider a fascinating experiment that demonstrates this principle beautifully. Researchers take the exact same wine and pour it into two different bottles. One bottle looks expensive, with elegant labeling and prestigious branding. The other appears cheap, with basic packaging and no-frills presentation. When people taste the wine from both bottles, they consistently describe dramatically different experiences. The expensive-looking bottle produces reports of richer flavors, smoother texture, more complex aromatic notes, and higher overall quality. Yet the wine is molecularly identical in both containers. This happens because perception is fundamentally a collaboration between incoming sensory signals and your brain as internal predictive models. Your brain is constantly generating its best guess about reality, then checking that guess against the actual evidence arriving from your senses. When the expectation is strong enough, particularly when it's reinforced by visual cues, social context, or authoritative framing, it can effectively drown out contradictory information entirely. You're not lying when you say the expensive wine tastes better. Your actual conscious experience has genuinely changed based on expectation alone. The beautiful and empowering implication of this discovery is that expectations are trainable and modified through deliberate practice, conscious awareness, and repeated exposure to new patterns. You can reshape what you habitually anticipate in any given situation. And when you change what you expect, you genuinely change what you perceive and experience. The external world hasn't shifted at all, but your subjective reality has transformed completely. Fact 2. Placebo pills can trigger measurable biological responses. The placebo effect is far more sophisticated and profound than simple imagination, wishful thinking, or the power of positive attitude. When someone genuinely believes they have received effective treatment, their body can produce real, measurable biological responses. Even when the treatment contains absolutely no active pharmaceutical ingredients whatsoever. Give someone a sugar pill and tell them with confidence that it's a powerful painkiller, and their brain may actually begin releasing endogenous opioids, which are the body's own naturally produced morphine-like substances. Researchers have proven this mechanism definitively by administering naloxone, a medication that specifically blocks opioid receptors in the nervous system. When naloxone is given to someone experiencing placebo pain relief, that relief vanishes almost immediately, demonstrating conclusively that real neurochemical changes were involved in creating the original effect. The same remarkable phenomenon appears across multiple physiological systems. Placebo treatments have been shown to influence heart rate, breathing patterns, blood pressure regulation, hormone release, and even immune system markers in controlled experimental settings. Interestingly, the strength of the placebo response can be influenced by factors that seem almost absurdly superficial. The color of the pill matters, with blue pills tending to produce more sedative effects, while red pills create more stimulation, despite containing identical inert substances. The size of the pill influences perceived potency. Even the price tag attached to the treatment can nudge the response magnitude up or down. This reveals something truly profound about human biology and the nature of healing. The context, ritual, and meaning surrounding any treatment become part of the treatment itself, not separate from it. Your nervous system is always listening carefully for environmental and social cues about safety, care, hope, and the likelihood of recovery. When those signals clearly indicate that help is arriving, that competent care is being provided, and that improvement is expected, your body may spontaneously activate healing and regulatory responses that were present all along, simply waiting for the right signal to engage fully. Fact 3. Negative expectations can create real physical harm just as positive expectations can trigger healing responses. Negative expectations can create genuine physical harm and suffering. This darker mirror image of the placebo effect is known scientifically as the nocebo effect, and it demonstrates with disturbing clarity how powerfully our anticipations and interpretations shape physical reality and bodily experience. In clinical research trials, participants who are given completely inactive pills but explicitly warned about potential side effects frequently report experiencing exactly those symptoms with remarkable consistency. Headaches, nausea, fatigue, dizziness, muscle aches, digestive disturbances, and numerous other complaints can all emerge from substances that contain nothing but inert fillers, simply because the mind has been primed to expect trouble and interpret bodily sensations through that lens of anticipated threat. Brain imaging studies conducted during nocebo responses reveal activation patterns in threat processing neural networks. The brain genuinely interprets the warning information as a danger signal, which triggers a cascade of defensive physiological preparations. Stress hormones begin circulating at elevated levels. Muscle groups tighten protectively. Sensitivity to uncomfortable sensations increases significantly throughout the body. What began as nothing more than a thought or verbal warning becomes a measurable cascade of biological changes that create real suffering. This is precisely why the specific language that healthcare providers use matters so profoundly in clinical settings. Telling someone that an upcoming procedure will be excruciatingly painful versus describing it as briefly uncomfortable or tolerable can literally alter how much pain they actually experience, even though the physical stimulus remains absolutely identical. The same needle insertion, the same surgical incision, the same diagnostic procedure, filtered through different expectations and verbal framings, creates entirely different subjective realities for the person undergoing it. In this very real sense, words become a form of medicine or poison depending entirely on how they shape what the mind anticipates and how the body prepares. Fact 4. Your focused attention acts like a volume dial for pain. Pain is not simply a direct, objective readout from damaged or injured tissue traveling up to your conscious awareness. Instead, it's a complex interpretation actively created by your brain, and that interpretation can be dramatically adjusted up or down by where you choose to place your attention and how you direct your conscious focus. Deep within the brainstem, beneath conscious awareness, lies an intricate network of neurons, known as the descending pain modulation system. This network possesses the remarkable ability to amplify or suppress pain signals before they ever reach conscious awareness and get interpreted as suffering. This system responds powerfully to attentional focus, emotional state, perceived safety, and contextual meaning. When you're completely absorbed in something compelling or urgent, pain signals may be dialed down to barely noticeable background levels, allowing you to function without distraction. This explains numerous puzzling observations from emergency medicine and combat situations. Soldiers injured during intense battle sometimes do you unrealize they've been wounded until the fighting stops and safety returns. During the peak of danger, when survival depends on continued movement and tactical awareness, the brain actively deprioritizes pain signaling to keep the body fully functional. Later, once the threat has passed and rest becomes appropriate, the volume gets turned back up substantially, and sensation floods into conscious awareness with full intensity, encouraging protection and recovery behaviors. The beautiful and empowering aspect of this system is that it's not purely automatic or beyond influence. With proper training and practice, many people can learn to consciously influence this attentional volume control to some degree. Meditation practices, guided imagery, techniques, absorption in meaningful activities, and even simple but deliberate distraction can reduce subjective suffering by redirecting the spotlight of awareness. The underlying injury or tissue damage hasn't changed at all, but the brain's interpretation of how urgent and threatening that signal is has shifted dramatically, changing the lived experience completely. Fact 5. Chronic stress fundamentally reprograms immune function. Your immune cells don't operate in biochemical isolation, making independent decisions about how to respond to threats. Instead, they're in constant, intimate communication with your nervous system, receiving continuous chemical updates about your psychological and emotional state throughout every single moment of every day. When you experience acute, short-term stress, your immune system intelligently shifts into a mode specifically designed for potential physical injury. Inflammatory responses ramp up in anticipation, preparing cellular defenses to fight infection in case you sustain wounds during whatever threatening situation triggered the stressed response. This makes perfect evolutionary sense for the short-term dangers our ancestors faced, like escaping predators, engaging in physical conflicts, or navigating dangerous terrain where injury was a genuine possibility. But when stress becomes chronic and unrelenting, stretching across weeks, months, or even years, these carefully calibrated immune signals don't shut off properly. Instead, they can become dysregulated and chaotic. Inflammation can remain persistently elevated, even without any infection present to justify it. This prolonged inflammatory state has been scientifically linked with slower wound healing rates, increased susceptibility to various illnesses, worsening symptoms in autoimmune conditions, and numerous other health complications that compound over time. The encouraging discovery that offers hope is that this relationship works practices in conditions that successfully signal safety to your nervous system, such as consistent, restorative sleep, genuine social connection and support, and regular relaxation techniques, can actively help recalibrate immune function back toward healthier baselines. Scientific studies have found that even brief, daily meditation practices, when performed consistently over several weeks rather than just once or twice, correlate with measurable changes in inflammatory marker levels. Your thoughts and interpretations about safety versus threat literally become chemical messengers that your immune cells receive and respond to, adjusting their activity patterns accordingly. Fact 6. Controlled breathing can rewire your nervous system within minutes. Breathing occupies a unique and powerful position among all bodily functions. It operates completely automatically when you're not thinking about it, maintaining itself reliably during sleep and unconsciousness. Yet, unlike heartbeat, digestion, or hormone release, you can seize conscious control of your breathing pattern whenever you choose. This remarkable dual nature makes breathing an extraordinarily powerful bridge between voluntary and involuntary physiological systems. When you deliberately slow and extend your exhalation, making it longer than your inhalation, you directly activate the vagus nerve, which is a major communication pathway connecting your brain to your heart, lungs, digestive system, and numerous other internal organs. This nerve functions like a dedicated messenger of calm, carrying signals that tell your body it's safe to relax, restore, and stand down from defensive alert states. Within just a few breath cycles, sometimes as quickly as 60 to 90 seconds, you can trigger a cascade of measurable physiological changes throughout your body. Heart rate typically decreases noticeably. Blood pressure may drop slightly in many individuals. Heart rate variability, which is a subtle pattern in heartbeat timing that's often associated with stress, resilience, and adaptive flexibility, frequently increases. These aren't subtle changes, only detectable with extraordinarily sensitive laboratory equipment. Many people can actually feel the shift happening in their body's state, experiencing it as a wave of settling or release. What makes this intervention especially remarkable and clinically valuable is how rapidly it can work compared to other approaches. Unlike many behavioral or pharmaceutical interventions that require weeks or months of consistent application before showing meaningful effects, breathwork can begin altering your physiological state almost immediately. This ancient practice, discovered independently in cultures worldwide throughout human history, turns out to have solid, well-understood neurological mechanisms underlying its effectiveness. You're not just imagining a sense of calm or trying to think your way to relaxation. You're actively creating measurable change through direct engagement with nervous system pathways. Fact 7. Long-term meditation physically reshapes your brain structure. Meditation is often casually described as simply a way to feel peaceful, temporarily, or to take a mental break from stress. But when practiced regularly and consistently over months and years, it can actually produce measurable changes in the physical structure of your brain that persist even when you're not actively meditating. Neuroimaging studies comparing experienced meditators with matched control groups have revealed significantly increased cortical thickness in specific brain regions associated with sustained attention, sensory processing, and emotional regulation. These are precisely the same brain areas that tend to thin gradually with normal aging processes, which suggests that consistent meditation practice might actually counteract or slow some aspects of age-related cognitive decline. Even people who are completely new to meditation can show detectable changes surprisingly quickly. 8-week mindfulness-based stress reduction programs have been linked with measurable differences in brain regions involved in learning, memory consolidation, emotional control, and perspective-taking in some carefully controlled experiments. The changes aren't dramatic wholesale restructuring, but they are statistically significant and functionally meaningful. What's happening at a cellular level is neuroplasticity in action. Your brain physically adapts and remodels itself in response to what you practice most consistently and what demands you place on it repeatedly. Just as juggling practice has been shown to increase gray matter density in visual and motor coordination areas, meditation practice appears to strengthen and elaborate the neural machinery responsible for awareness, attention control, and emotion regulation. The mind is quite literally reshaping its own physical hardware through the consistent application of mental software. Through the repeated practice of specific patterns of attention and awareness, this transforms meditation from a purely subjective, ephemeral practice into something with objective consequences that neuroscience can track and study systematically. Fact 8. Hypnotic suggestion can alter how pain is processed. Hypnosis is frequently dismissed in popular culture as stage trickery, theatrical entertainment, or pseudoscientific nonsense. But in controlled medical and research settings, proper hypnotic techniques produce genuine and measurable effects on pain perception and processing that go far beyond simple distraction or theatrical performance. During properly induced hypnotic states, brain imaging technology reveals significant changes in neural networks that process the affective and evaluative dimensions of pain, the parts that handle emotional meaning and personal significance, not merely the raw sensory detection. People under hypnosis may describe pain sensations as feeling distant, dull, unimportant, or simply different in fundamental character, even though the actual painful stimulus being applied to their body hasn't changed in intensity at all. This capacity has found practical clinical applications in settings where pain management is challenging. Dental procedures, minor surgical interventions, burn wound care, and certain diagnostic tests have all been performed successfully with hypnotic suggestion serving as the primary or supplementary pain control method, sometimes reducing or even eliminating the need for pharmaceutical anesthesia in carefully selected patients. It's crucial to understand that hypnosis isn't mind control or magical power over another person. It works best as a collaborative process where the person voluntarily follows suggestions, somewhat like engaging with a guided simulation or entering deeply into a narrative. Some researchers compare the hypnotic state to turning down competing mental processes and worries so that one specific idea or suggestion can dominate conscious experience without interference. Not everyone responds equally well to hypnotic induction. Researchers identified that some individuals are highly hypnotizable and respond dramatically, while others barely respond at all, regardless of technique. But for those who do respond well, it offers a fascinating window into just how malleable and interpretive pain actually is. The nervous system can be verbally guided to reinterpret suffering through nothing more than focused attention combined with carefully crafted suggestions. Fact 9. Vivid mental imagery activates the same brain networks as real experience. Close your eyes right now and imagine vividly biting into a fresh, sour lemon. Picture the bright yellow rind. Imagine the citrus smell. Visualize the juice running as your teeth break through. Many people will notice their mouth beginning to produce saliva, their face perhaps scrunching slightly, even though absolutely no lemon is physically present anywhere near them. This simple demonstration reveals something profound about how your brain handles imagination versus reality. When you engage in vivid, detailed mental imagery of any experience, many of the exact same neural networks activate as when you actually live that experience in the physical world. Imagining movement lights up motor cortex regions. Imagining sounds activates auditory processing areas. Imagining smells can trigger responses in olfactory regions. The overlap isn't complete or identical. Real experience typically produces stronger and more widespread activation patterns, but the similarity is striking enough that mental rehearsal and visualization have become standard, evidence-based training tools for athletes, musicians, surgeons, and performers across numerous domains. What this fundamentally means is that imagination is owned, neurologically separate from reality in your brain. Basic architecture: they recruit and utilize overlapping neural machinery and pathways. This is precisely why visualization can feel so remarkably vivid and compelling, why memories, when recalled intensely, can seem almost real and present, and why the boundary between thought and perception turns out to be far more permeable and blurred than we typically assume in everyday experience. This has profound implications. Mental practice isn't just theoretical preparation or abstract planning, it's actual neural activation that strengthens pathways, refines timing, and builds patterns that will be called upon during real performance. Your brain treats vivid imagination as a form of experience, learning from it and adapting to it accordingly. Fact 10. Your body responds to imagined threats as though they're real. Your autonomic nervous system evolved over millions of years in environments where threats were immediate, physical, and present in the current moment. It simply has unfully adapted to the modern world, where the vast majority of threats exist purely as thoughts about the uncertain future or memories of the difficult past. When you lie awake at night worrying about tomorrow's important presentation, your body may respond with precisely the same physiological cascade it would deploy for escaping an actual predator bearing down on you. Heart rate increases significantly. Breathing becomes rapid and shallow. Major muscle groups tense in preparation for action. Stress hormones, including cortisol and adrenaline, flood through your bloodstream in substantial quantities. The threat isn't real in this present moment. It's not actually happening right now. But your biological threat detection systems do not distinguish very well between actual immediate danger and vividly imagined potential danger. Both categories trigger the same ancient alarm mechanisms that evolved to prepare your body for fight or flight responses. This creates a peculiar and exhausting trap. Your conscious mind spins elaborate stories about potential problems, worst-case scenarios, and things that might go wrong. And your body treats those mental stories as if they're happening right now in present reality. The exhaustion that follows from chronic worry isn't imaginary or psychological weakness. It's genuine physical exhaustion, generated by a body that's been biochemically preparing for vigorous action that never actually comes, burning through energy resources in preparation for threats that never materialize. Understanding this feedback loop represents the crucial first step toward interrupting it. When you recognize that your body is responding to thoughts rather than to present reality, you create the possibility of intervening, of changing the mental input that drives the physical response. Fact 11. Worried thoughts trigger muscle tension before conscious awareness muscle. Tension frequently arrives in your body before you consciously register that you're feeling stressed or anxious. Your brain detects a threat signal, whether that threat is real, remembered, or purely imagined, and immediately begins preparing your physical body for a protective action through motor pathways that can completely bypass conscious thought and deliberate decision. This preparation happens through ancient motor control circuits that prioritize speed over awareness. Within mere milliseconds of a worry arising, muscles throughout your jaw, shoulders, neck, back, and abdomen may begin contracting and bracing. Over extended time periods, if stress remains chronically elevated and never fully resolves, this protective tension can actually become your new baseline state, the default setting your body returns to automatically. Many people move through their entire day carrying significant muscle guarding without any conscious awareness of it, until someone specifically points it out, or until persistent pain and fatigue finally develop and demand attention. The body has essentially learned to stay perpetually braced and ready, as if danger might arrive at absolutely any moment, even during objectively safe situations. What makes this pattern especially tricky and self-perpetuating is the feedback loop it creates. Tight, contracted muscles send continuous signals back upward to the brain through sensory pathways. These tension signals can be unconsciously interpreted as confirmation that something is indeed wrong or threatening, which maintains and reinforces the entire state of vigilance and defensive arousal. The brain receives evidence supporting its worry, even though that evidence was created by the worry itself. Breaking this self-reinforcing cycle often requires developing the skill of consciously scanning your body with curious attention and deliberately releasing accumulated tension that you didn't even know you were holding, interrupting the loop before it spirals further. Fact 12. Extended exhalation recalibrates carbon dioxide sensitivity. Many people experiencing panic attacks assume the problem is insufficient oxygen reaching the brain and lungs. But the real physiological culprit driving most panic sensations is actually carbon dioxide levels in your brain's sensitivity to normal fluctuations in CO2 concentration in your bloodstream. Your brain monitors carbon dioxide levels with extraordinary precision and sensitivity, using CO2 as the primary chemical signal for determining when breathing needs to increase or decrease. When anxiety chronically heightens this monitoring sensitivity over time, even completely normal, harmless fluctuations in carbon dioxide can trigger intense alarm responses and overwhelming sensations of suffocation or air hunger. The anxious brain interprets slight, natural increases in CO2 as dangerous oxygen deprivation, which triggers rapid, desperate breathing in an attempt to get more air. But this rapid breathing actually lowers carbon dioxide too quickly, creating dizziness, tingling in extremities, and lightheadedness that intensify the fear dramatically, creating a terrifying spiral. Extended, controlled exhalation works through an entirely different mechanism. By consciously lengthening the outward breath while maintaining a steady, predictable rhythm, you actively stabilize the breathing pattern and reduce wild swings in blood chemistry that trigger alarm. Over repeated consistent practice across days and weeks, the brain's alarm threshold for CO2 changes can gradually shift upward, becoming less reactive. This represents retraining sensitivity through safe, controlled exposure. Gradual, deliberate practice teaches your nervous system experientially that normal bodily sensations occurring during breathing are fundamentally safe, not dangerous or life-threatening. The panic response becomes less hair-trigger and reactive. What once felt unbearably like suffocation begins to feel tolerable, then gradually normal and unremarkable. Fact 13. Biofeedback makes invisible body processes visible and trainable. Biofeedback technology takes physiological processes that normally operate completely outside conscious awareness and makes them visible and observable. Through real-time measurement and display, temperature sensors track minute changes in fingertip warmth. Heart rate monitors display pulse patterns. Muscle tension gauges show contraction levels. All provide immediate, objective information about what your body is actually doing moment by moment. With this external mirror reflecting your internal state, people can begin learning to influence bodily systems that typically run on complete autopilot. One particularly well-studied example is thermal biofeedback, where someone watches their displayed fingertip temperature in real time and gradually learns through experimentation which mental states, breathing patterns, and attention focuses cause the small blood vessels in their fingers to dilate or constrict, changing temperature. After sufficient dedicated practice, many individuals can learn to intentionally warm their hands by several degrees, which physiologically signals reduced sympathetic nervous system activation and increased parasympathetic dominance. This seemingly simple skill has been explored therapeutically for migraine management, Raynaud's phenomenon, and various stress-related conditions because it trains direct regulation rather than mere distraction or cognitive What makes biofeedback especially valuable psychologically is that it provides undeniable proof and concrete evidence. You can literally watch your biology changing in direct response to your mental approach and attentional strategies. This external validation helps convince the skeptical conscious mind that voluntary control is genuinely possible, not wishful thinking, which paradoxically makes the skill easier to develop and eventually internalize completely. Once the pattern is learned deeply through sufficient repetition, the external sensor often becomes unnecessary. The body remembers the pathway and can access it independently. Fact 14. Mental rehearsal alone can increase physical strength. Elite athletes across virtually every sport have understood for decades that mental practice produces genuine, measurable performance improvements that translate directly into competition and physical execution. When you vividly and repeatedly imagine executing a specific movement with clear intention and sensory detail, your motor cortex activates in spatial and temporal patterns, remarkably similar to actual physical performance of that same movement. Scientific studies have measured actual strength gains resulting from mental training alone, particularly when imagination is combined strategically with physical practice sessions. The mechanism underlying these gains isn't building additional muscle tissue or increasing muscle fiber size. Instead, it's refining and optimizing the neural blueprint, the precise pattern of nerve signals that controls how efficiently, completely, and coordinately those existing muscles are recruited and activated. This mental rehearsal dramatically reduces hesitation, smooths timing, and improves coordination between muscle groups. The movement pattern becomes more deeply and precisely etched into nervous system pathways, making execution feel increasingly automatic, confident, and reliable when the actual performance moment finally arrives. The profound implication is that physical performance isn't only about muscles, tendons, and joints. It's equally about how clearly, confidently, and efficiently your brain can send exactly the right signals at exactly the right moments in exactly the right sequence. Training the mind through detailed visualization sharpens that signal pathway significantly, making the entire integrated system operate more effectively. This is why injured athletes often maintain visualization practice, even when physical training is impossible. The mental repetition keeps neural pathways active and refined, minimizing skill degradation during forced physical rest periods. Fact 15. Phantom sensations prove pain originates in brain interpretation. After limb amputation, the vast majority of people continue experiencing vivid, detailed sensations that seem to originate from the body part that no longer physically exists. Fingers might itch intensely, hands might cramp painfully, or feet might burn, despite there being literally no remaining tissue in those locations. This phenomenon, known as phantom limb sensation, offers profound and undeniable insight into pain's true neurological nature. These compelling experiences emerge because your brain maintains an extraordinarily detailed internal map of your entire body that doesn't immediately update or reorganize when physical anatomy changes through surgery or trauma. Nerve signals from nearby remaining areas can inadvertently activate this outdated internal map, creating sensations that feel absolutely real and precisely located in specific positions in three-dimensional space. When phantom sensations become intensely painful rather than merely odd or uncomfortable, the implications become particularly revealing and important. The pain is completely genuine and causes real suffering, yet there exists no damaged tissue whatsoever causing or generating it. This demonstrates conclusively and irrefutably that pain is fundamentally a perception, actively constructed by brain interpretation, not a simple alarm signal passively transmitted from injured body areas. This revolutionary understanding completely transformed modern pain medicine and treatment approaches. If the brain can generate profound suffering without any tissue damage present, it logically follows that chronic pain might persist indefinitely even after physical injuries have completely healed. The nervous system itself can become sensitized and hyperreactive, continuing to produce pain as a learned habitual pattern long after the original protective purpose has expired. Understanding this mechanism opened entirely new treatment pathways focused on retraining brain interpretation rather than only targeting damaged tissue. Fact 16. Mirror therapy reprograms body maps through visual contradiction. Mirror therapy emerged directly from understanding phantom limb pain mechanisms by carefully positioning a mirror so that the visual reflection of an intact healthy limb appears precisely where the missing limb would be located. The brain receives compelling visual feedback, suggesting that both limbs are present intact and moving normally together. For many people experiencing phantom pain, particularly when the missing limb feels frozen, cramped, or stuck in painful positions, this elegantly simple visual trick can produce dramatic pain reduction. The brain's expectation of seeing movement confirmation when it sends motor commands is satisfied by the mirror reflection, which can significantly calm the alarm signals and reduce suffering. This technique revealed with striking clarity how powerfully vision influences and even dominates bodily experience. Your eyes are providing sensory information that directly contradicts what you consciously know to be true about your body. Yet, the brain accepts and integrates the visual evidence, and adjusting its internal predictive model accordingly to match what the eyes report. Modern technological versions, using sophisticated virtual reality systems, create responsive digital limbs that move precisely in response to the user's intentions, brain signals, or movements of remaining body parts, providing even more elaborate and convincing feedback. These cutting-edge approaches aim to systematically update the brain's outdated body maps and prediction systems, reducing suffering through achieved coherence and consistency rather than through pharmaceutical suppression. The deeper lesson is that perception can be therapeutically manipulated. When different sensory streams are brought into alignment and agreement, suffering often diminishes naturally as the brain resolves its internal contradictions. Fact 17. Prolonged stress shrinks memory-critical brain regions. The hippocampus, a seahorse-shaped structure deep within the brain that plays absolutely crucial roles in memory formation, emotional regulation, and spatial navigation, turns out to be particularly vulnerable to damage from chronic, unrelenting stress exposure. Repeated, sustained flooding with stress hormones, especially cortisol during prolonged elevation, can actively interfere with normal neural growth processes and synaptic connectivity in this sensitive and metabolically demanding region. Carefully controlled animal research has demonstrated measurably reduced dendritic branching, fewer newly generated neurons, and decreased synaptic complexity under sustained stress conditions that mimic chronic human anxiety and adversity. Human neuroimaging studies have found statistically significant correlations between prolonged stress exposure and observable differences in hippocampal volume and functional performance on memory tasks. This neurological damage helps explain the frustrating cognitive fog that so commonly accompanies chronic stress states. Memory formation becomes noticeably less efficient and reliable. Emotional regulation feels increasingly difficult and exhausting. Learning and retaining new information requires substantially more effort and repetition. The brain is literally operating with compromised hardware in critical regions. The genuinely hopeful and encouraging counterpoint to this sobering information is neuroplasticity, and the brain has remarkable capacity for recovery. When stress finally diminishes and supportive environmental conditions return, the hippocampus demonstrates impressive ability to recover function and potentially even structural integrity. Quality sleep, regular physical exercise, cognitively enriching experiences, and effective therapeutic support are all strongly associated with improved cognitive function and potential structural recovery over time. The brain is resilient. Damage from stress isn't necessarily permanent if conditions change favorably. Fact 18. Safe touch signals safety and alters stress biochemistry. Human beings possess specialized nerve fibers embedded in skin tissue that respond specifically and preferentially to gentle, caring touch rather than to pressure, pain, or temperature. These C-tactile afferents connect directly to brain regions centrally involved in emotional processing and social bonding rather than two areas that simply map physical sensation locations. When someone receives comforting, caring contact from a genuinely trusted person in a safe context, it can trigger objectively measurable reductions in circulating cortisol levels and DECREASE. Activity and threat monitoring brain networks, visible on functional imaging. The body physiologically interprets safe, consensual touch as compelling evidence that immediate danger is not present in the environment. This isn't merely emotional comfort or psychological reassurance. It's a direct physiological signal that can measurably influence heart rate patterns, breathing depths, and rhythm, muscle tension levels throughout the body, and pain perception thresholds. In medical settings, remarkably simple interventions like compassionate hand-holding during uncomfortable diagnostic procedures have been associated with better tolerance, lower distress ratings, and improved patient experiences. Touch becomes a fundamental form of nervous system communication that completely bypasses language and cognitive interpretation. The physical contact delivers a direct biological message through dedicated neural pathways. You are not alone in this moment. You are fundamentally safe. Help and support are immediately present and available. That simple message can dramatically reshape the biological and neurological landscape within which pain, fear, and suffering operate, often producing relief that words alone cannot achieve. Fact 19. Shared laughter releases bonding chemicals and buffers. Pain laughter triggers a remarkably complex cascade of physiological changes throughout multiple body systems simultaneously. Breathing becomes rhythmic and deep, fully engaging the diaphragm. Facial muscles engage in highly specific patterns. Stress hormones often decrease measurably. And crucially, the brain releases endorphins, which are natural chemicals intimately involved in both social bonding and pain modulation systems. Research has documented that people can tolerate objectively uncomfortable stimuli significantly longer after episodes of genuine, shared laughter. The social element appears particularly important and powerful. Laughing in complete isolation produces measurably weaker effects than laughing together with others, strongly suggesting that the bonding and social safety components substantially amplify the underlying chemical response. This pattern makes excellent evolutionary sense when examined functionally. Laughter frequently signals safety, playfulness, and strong social cohesion within a group. In that fundamental context of demonstrated safety and belonging, the body may intelligently reduce protective vigilance and increase tolerance thresholds, operating under the reasonable assumption that if there's sufficient safety for play and humor, serious immediate threats must be genuinely absent. While laughter obviously isn't a medical treatment for serious illness or injury, it beautifully illustrates how emotional and social states can directly influence physical thresholds and experiences. Something as ordinary, accessible, and universally human as shared humor can temporarily recalibrate how much discomfort the nervous system will permit before triggering withdrawal and protective responses. The body integrates social and emotional information when setting its sensitivity levels. Fact 20. Infant nervous systems require external regulation from caregivers newborn. Babies cannot effectively regulate their own physiological states independently. They fundamentally depend on attentive caregivers to provide external regulation through gentle touch, rhythmic movement, soothing vocalizations, and consistent presence during distress. When a distressed infant hears a familiar, soothing voice characterized by steady rhythm and warm pitch, their breathing rate and heart rhythm often stabilize noticeably within moments. The caregiver's regulated, calm, nervous system essentially lends itself temporarily to the baby's developing, immature one, actively helping establish and maintain patterns of physiological regulation. This crucial process, known scientifically as co-regulation, is absolutely foundational for gradually learning internal self-soothing capabilities over developmental time. Through literally thousands of repetitions of being reliably calmed by another person's presence and actions, the infant's nervous system slowly, gradually learns to access increasingly calm states independently. Remarkably, this fundamental sensitivity to soothing voices, caring touch, and regulated presence doesn't simply disappear in adulthood. Even fully grown humans continue responding physiologically to trusted voices during moments of significant distress. Vocal tone, rhythm, emotional quality, and conveyed confidence can still measurably influence another person's autonomic nervous system state. Echoing these earliest developmental patterns of comfort and safety, we remain, throughout life, fundamentally social beings whose nervous systems are designed to influence and be influenced by the regulated presence of trusted others. Primerus vinci fatus completus. Proximus des. Shore, 2052. Fact 21. The vagus nerve creates a communication highway between gut and brain. The vagus nerve serves as a massive, critically important information superhighway running bidirectionally between your brain and your internal organs. With particularly dense connections to your entire digestive system, signals travel continuously in both directions throughout every single moment of every day and night. From the gut traveling upward toward the brain, the vagus carries detailed, moment-by-moment information about feelings of fullness or emptiness, sensations of nausea or comfort, irritation or inflammation in intestinal walls, and complex chemical conditions throughout the digestive tract. This constant internal sensing helps your brain make sophisticated decisions about eating behaviors, rest requirements, and potential threat assessment. From the brain traveling downward toward digestive organs, vagus signals possess the power to dramatically speed digestion and increase gut motility, slow everything down to conserve energy, or even temporarily halt digestive processes completely when significant threat is detected in the environment. This explains precisely why intense fear can cause immediate stomach cramping, complete loss of appetite, or urgent bowel movements within mere moments. Practices and techniques that demonstrably enhance vagal tone, such as systematic slow breathing exercises, humming or singing, and certain meditative practices, can measurably improve this crucial bidirectional communication system. A well-functioning, high-tone vagus nerve is strongly associated with better overall stress resilience, improved digestive function and comfort, and more stable, balanced emotional regulation. The gut-brain connection people often reference casually is not metaphorical or abstract. It's a substantial physical nerve bundle carrying real, measurable electrical and chemical signals that profoundly shape both physiological state and subjective mood continuously. Fact 22. Your intestines contain an independent neural network, the enteric nervous system, intricately embedded throughout the muscular walls of your entire digestive tract, contains an astonishing estimated 200 to 600 million nerve cells. This massive network can coordinate remarkably complex digestive movements, precisely timed enzyme secretion, and sophisticated local immune responses with surprising operational independence from central brain control. When you experience butterflies, dropping sensations, twisting feelings, or significant tension in your belly during emotionally charged moments, you're directly feeling this extensive network responding to signals cascading down from the brain. Fear, excitement, anticipation, or dread can rapidly change muscular wave patterns throughout intestinal walls, creating intensely real physical sensations. The gut also manufactures and releases substantial quantities of serotonin, a neurotransmitter powerfully associated with mood regulation, emotional stability, and sense of well-being. While gut-produced serotonin doesn't directly cross the protective blood-brain barrier to enter the brain, it significantly influences gut sensation, motility patterns, and the constant stream of gut-brain signaling. This remarkable sophistication has earned the enteric system its popular nickname, the second brain, though it obviously doesn't think, reason, or make decisions in any conventional cognitive sense. What it does accomplish is process enormous amounts of information locally and independently, contribute to the constant, rich stream of internal signals that fundamentally shape your moment emotional experience. Your gut is not passively waiting for brain commands. It's an active, intelligent participant in creating your subjective experience of being alive. Fact 23. Scent triggers memory faster than any other sense. The olfactory system possesses uniquely direct wiring in brain architecture. Smell signals take a relatively short, privileged route to regions deeply and intimately involved in emotion processing and memory storage, particularly the amygdala and hippocampus, bypassing many intermediate processing stages that other senses must navigate. This distinctive architectural shortcut provides compelling explanation for why a particular fragrance can instantly, almost violently transport you to a specific childhood kitchen, a memorable summer afternoon, or a particular person's presence. The memory arrives with startling rapidity and often carries extraordinarily strong emotional coloring and atmospheric detail rather than just dry, factual information. Unlike carefully recalled visual or verbal memories, smell-triggered memories feel fundamentally less like conscious intellectual recall, and dramatically more like sudden, immersive re-experiencing. You're not merely remembering the moment analytically and objectively. You're almost living inside it again temporarily, complete with its original emotional atmosphere, physical sensations, and subjective feeling tone. This remarkable phenomenon reveals profound truths about how memories aren't stored as perfect, objective recordings waiting to be played back. They're reconstructed patterns and associations, and smell provides an especially potent, privileged cue for triggering that complex reconstruction process. A single airborne molecule reaching specialized receptors in your nose can unfold an entire detailed scene, demonstrating how intimately sensation and memory are fundamentally woven together. Scent is memory's most direct key, opening doors other senses must knock on repeatedly. Fact 24. Music synchronizes breathing and heart rate through rhythm. Your body demonstrates a natural, powerful tendency to synchronize with external rhythms present in the environment, a fascinating phenomenon. Scientists, when you listen attentively to music with a clear, consistent beat, your breathing rate, heart rate, and even subtle movement timing can gradually drift toward matching that external tempo without any conscious effort or intention. Slow, steady music with gentle rhythms often leads listeners towards slower breathing patterns and measurably reduced heart rate. Faster, more energetic music with driving beats can produce the opposite effect, increasing physiological arousal and physical readiness for action. This isn't conscious mimicry or deliberate matching. It's automatic coordination between auditory processing systems and motor control networks. In clinical rehabilitation settings, rhythmic auditory cues are systematically used to help people relearn movement timing after stroke or injury. The external beat provides a stable temporal scaffold that the damaged nervous system can lock onto, making movements feel more coordinated, confident, and precisely timed. The beautiful aspect of this phenomenon is its universality. Across vastly different cultures, throughout human history, people have instinctively used rhythm to coordinate group activity, systematically regulate internal arousal states, and create powerful shared emotional experiences. Your nervous system is fundamentally built to detect, respond to, and synchronize with temporal patterns in environmental sound. Music doesn't just influence mood abstractly. It directly, measurably influences your physiological state through rhythmic and Fact 25. External rhythm can reduce tremor by stabilizing motor timing. Tremor frequently stems from timing irregularities and coordination problems in the complex neural circuits that normally control smooth, fluid movement. A steady external beat can effectively provide a reliable reference clock that helps stabilize these malfunctioning circuits. People living with various movement disorders sometimes demonstrate remarkably smoother walking when stepping deliberately to rhythmic auditory cues. The predictable, consistent timing reduces uncertainty about precisely when to initiate each step, which helps the brain execute movements more evenly and confidently. This stabilizing principle appears prominently in music therapy, protocols, and evidence-based movement rehabilitation programs. The external rhythm essentially substitutes temporarily for internal timing mechanisms that have become unreliable due to neurological damage or disease, giving the compromised motor system something stable and predictable to follow. What's particularly remarkable is how minimal the intervention can be. A simple, steady pulse or beat can meaningfully influence deep motor control systems that otherwise feel completely beyond conscious reach or voluntary influence. The brain eagerly welcomes this external structure and actively uses it to organize behavior more effectively. This demonstrates that movement isn't purely internal generation. It's a dynamic interaction between internal planning and external structuring. When internal timing fails, external scaffolding can partially compensate, restoring function that seemed permanently lost. The right rhythm can unlock movement that disease had stolen. Fact 31. Anxiety amplifies normal sensations into urgent warnings. An anxious mind treats the body as a danger zone requiring constant surveillance. Every flutter, twinge, or shift in sensation becomes potentially meaningful and threatening. This hypervigilance creates a feedback loop. Attention focused on a sensation makes it feel stronger and more persistent. That increased intensity then feels like confirmation that something is wrong, which further elevates anxiety. The body responds to this worried attention with real changes. Stress hormones rise, muscles tighten, breathing becomes shallow. These changes create even more sensations. To notice and worry about spiraling the experience upward. Many panic attacks begin this way. A normal bodily fluctuation is misread as danger, triggering alarm that produces more sensations, which reinforce the danger interpretation. Breaking this cycle requires learning that urgency and intensity don't automatically mean danger. Sensations can be allowed without interrogation, and they often settle when given space. Fact 32. Labeling emotions reduces amygdala activation measurably. When strong emotion arises without words, your amygdala, a brain region involved in threat detection, can remain highly active. Simply finding language for what you're feeling can lower this activation. Brain scans show that naming an emotion, even with a single word like anxious or frustrated, recruits prefrontal regions involved in regulation. This appears to reduce the raw intensity of the amygdala's response. The emotion doesn't vanish, but it becomes more manageable. The act of labeling creates a small distance between the feeling and your identity. You shift from "I am terrified" to "I'm noticing fear," which is a subtle but powerful This skill can be taught and practiced. Children guided to name their feelings show better emotional regulation over time. Adults can relearn this practice during difficult moments. A simple phrase transforms overwhelming sensation into identifiable information, giving the nervous system clearer navigation. Fact 33. Reinterpreting stress as preparation improves performance. Stress produces a characteristic set of bodily sensations: racing heart, quick breathing, heightened alertness. These can be interpreted as panic and danger, or as readiness and energy. Research shows that people taught to reframe stress as helpful preparation often perform better under pressure, even though their physiological arousal looks identical to those experiencing debilitating anxiety. The difference lies in meaning. When rapid heartbeat is labeled as your body preparing you to meet a challenge, it becomes a resource rather than a threat. The same sensation, interpreted differently, produces different psychological and behavioral outcomes. Athletes and performers often use this reframe naturally, treating nervousness as a sign that they're ready and engaged. The discomfort remains, but the story changes, and the story you tell about arousal shapes whether that energy enhances or undermines what you were trying to accomplish. Fact 34. A physiological sigh can reset breathing patterns quickly. The physiological sigh is a specific breathing pattern. A quick inhales through the nose followed by a long, slow exhale. This pattern naturally occurs after crying or prolonged stress, as if the body is pressing a reset button. The double inhale helps reinflate tiny air sacs in the lungs that can collapse during shallow breathing. The extended exhale activates parasympathetic nervous system pathways that promote calm. Using this pattern intentionally can interrupt rising panic or accumulated tension. Muscles often soften noticeably after a well-executed physiological sigh, and the subjective sense of overwhelm frequently diminishes. This technique works without requiring belief or concentration. It's a direct mechanical intervention in breathing chemistry and nervous system balance. One well-timed sigh can shift the body from escalating alarm toward gradual settling. Fact 35. Blushing demonstrates how social emotion becomes visible. Biology occurs when small blood vessels in facial skin dilate rapidly in response to social-emotional activation. The trigger is typically self-consciousness or awareness of being observed. Warmth and color spread across the cheeks, ears, or neck within seconds, completely beyond conscious control. You cannot suppress blushing through willpower, which makes it a uniquely honest signal. Some researchers propose that blushing evolved as a social signal, showing others that you recognize a social misstep and feel appropriate concern. It's a visible demonstration of social awareness. What makes blushing fascinating is its directness. A thought about reputation or judgment becomes immediate change in blood flow patterns. Social meaning is translated into physiology without intermediate steps. The boundary between mind and body essentially vanishes. Fact 36. Embarrassment triggers measurable changes in facial blood flow. The mechanism behind blushing involves rapid dilation of facial capillaries in response to autonomic nervous system signals. During embarrassment, commands increased blood flow to the face, specifically. This happens faster than conscious awareness often catches up. You may feel the warmth before you've fully processed what you're embarrassed about. That speed reveals how quickly social evaluation becomes bodily experience. Individual variation is significant. Some people blush readily while others rarely do. But the underlying pathway exists in everyone. To hide embarrassment sometimes intensifies it because attention remains locked on the reaction. In social contexts, blushing can actually invite understanding rather than ridicule. It signals that you care about social norms and recognize when you've violated them. A vascular response becomes subtle communication, demonstrating once again how meaning moves through biology. Fact 37. The startle reflex proves action can precede conscious awareness. A sudden loud noise triggers a full-body startle response before you have any idea what made the sound. Eyes blink, shoulders hunch, muscles brace, all within a fraction of a second. This reaction travels through ancient brainstem circuits designed for speed rather than accuracy. The system assumes danger first and asks questions later. Because in evolutionary terms, false alarms were far less costly than missed threats. Conscious recognition arrives afterward, sometimes noticeably delayed. You jump first, then your thinking mind catches up and evaluates whether the threat was real. This demonstrates that much behavior is automated below awareness. The narrative that you consciously decide all your actions is simply false. Many responses execute themselves, and consciousness arrives to explain what has already happened. Fact 38. Heartbeat timing can influence fear intensity. Each heartbeat sends signals to the brain about the body's internal state. During fear-inducing situations, research suggests that these cardiac signals can be integrated with external threat cues, potentially amplifying the emotional experience. When your heart pounds, the brain receives that information and may interpret it as confirmation that danger is genuine. The physiological arousal becomes evidence supporting the fear narrative. This helps explain why anxiety can spike after caffeine, illness, or poor sleep. When the heart rhythm is already elevated or irregular, external situations may feel more threatening than they would with a calm, steady pulse. Conversely, practices that stabilize heart rhythm, such as paced breathing, can reduce how threatening situations feel. The pulse provides constant background information that colors every emotional assessment you make. Fact 39. People misinterpret their own emotions when arousal source changes. The brain often uses bodily arousal as evidence when determining what emotion you're experiencing. When that arousal comes from an unexpected source, misattribution can occur. Classic experiments show that people rate situations as more exciting or threatening when their heart is already racing from exercise or caffeine. The elevated arousal is attributed to the current situation rather than its actual cause. This isn't deliberate confusion. It's the brain making reasonable inferences from available data. If your pulse is high and you're in an uncertain situation, it's logical to conclude that the situation is causing the arousal. Understanding this can reduce unnecessary panic. Sometimes a racing heart simply means you drank coffee, exercised recently, or didn't sleep well. The emotional interpretation can be questioned rather than automatically accepted as truth. Fact 40. Hunger alters social perception and threat detection. When blood sugar drops and hunger rises, the brain becomes more sensitive to potential threats and frustrations. This isn't just a mood. It's a measurable shift in how neutral information gets interpreted. Studies have found that hungry participants rate neutral facial expressions as more hostile or unfriendly than well-fed participants do. The same ambiguous face looks different depending on the body's energy state. This happens because depletion shifts the nervous system toward a more defensive stance. Resources are low, so the brain becomes more vigilant and less generous in its interpretations. The practical implication is simple but important. Sometimes what feels like a hostile world is actually a hungry brain asking for fuel. Nourishment can literally change social perception, softening interactions that felt tense moments before. Fact 41. Sleep deprivation amplifies pain and reduces emotional regulation after insufficient sleep. The body becomes more sensitive to pain signals and less capable of managing emotional reactions. This is measurable both subjectively and in brain activity patterns. Pain that would be tolerable after a good night. The sleep can feel significantly worse when you are exhausted. The brain's natural pain modulation systems function less effectively, allowing signals to come through louder. Emotional control also suffers. The prefrontal regions that help regulate reactions work less efficiently when sleep deep. While emotional reactivity centers may become more active, small frustrations feel larger, and recovery from upset takes longer. The encouraging flip side is that restoring sleep restores resilience. One solid night doesn't fix everything, but it can noticeably change how the same body and the same challenges feel the next day. Fact 42. Believing you slept well can improve next-day performance in experiments where people are told they slept exceptionally well, even when objective measurements show ordinary sleep. Many report feeling more alert and perform better on cognitive tasks. This placebo sleep effect demonstrates how expectations about restedness influence actual function. If you believe you're well rested, you may stop scanning for fatigue signs and start acting capable, which changes outcomes. This doesn't mean sleep is unnecessary. Real rest remains essential for health, but it shows that the experience of tiredness is partly interpretive. The story you tell yourself about your sleep quality influences how you feel and perform. Confidence in your restedness can reduce self-monitoring and doubt, freeing mental resources for the task at hand. Belief doesn't create energy from nothing, but it can change how fully you access the energy you have. Fact 43. Dreams may rehearse emotional challenges. In safe simulation, dreams often carry emotional themes that mirror waking concerns. Being pursued, losing something important, arriving unprepared. One theory suggests this serves a rehearsal function. During sleep, particularly REM stages, the brain may be processing emotional experiences and practicing responses in a consequence-free environment. It's like a nightly simulator where reactions can be tested without real-world stakes. This process might help consolidate learning about which situations are dangerous and which are safe. After difficult experiences, dreams may replay scenarios repeatedly, gradually reducing the emotional charge through repeated exposure. Not all dreams serve this function, and nightmares can be the painful side effect, especially after trauma. But the broader idea is compelling. While you lie still, your sleeping brain may be training for emotional challenges, practicing responses in the dark. Fact 44. Lucid dreamers can send deliberate signals from inside dreams. Lucid dreaming occurs when you become aware you're dreaming while the dream continues. Researchers found an ingenious way to verify this. Prearranged eye movement signals. During REM sleep, most muscles are paralyzed, but the eyes can still move. Lucid dreamers can perform a specific eye movement pattern once they achieve awareness, and that signal appears clearly on sleep monitoring equipment. This creates an astonishing communication channel. A sleeping person sending deliberate messages from inside their dream state. It proves that self-awareness can activate during sleep, creating a hybrid consciousness state. Lucid dreaming has been explored for reducing nightmares, enhancing creativity, and practicing skills in vivid imagery. The key insight is that consciousness has multiple modes and levels, not just waking and sleeping. Fact 45. Imagining sense can activate olfactory processing regions. When you vividly imagine a distinctive smell, sukas, fresh brewed coffee, ocean salt water, or pine forest, brain regions directly involved in actual scent processing can show measurable activity, though typically weaker than with genuine odors physically present. This partial overlap between vivid imagination and real perception helps explain why olfactory memories can feel so remarkably physical and present. The brain stores sensory experiences in complex networks that can be partially reactivated through focused thought alone, without any actual molecules stimulating nasal receptors. Professional perfumers and skilled sommeliers often deliberately train this imaginative ability, systematically building detailed internal libraries of scents they can mentally manipulate, compare, and blend without any physical samples present. The skill demonstrably strengthens with consistent, focused practice over time. This reveals imagination as substantially more than abstract thinking occurring in some non-physical mental realm. It's controlled, intentional activation of genuine sensory processing machinery. When you imagine a smell vividly enough, your brain measurably recreates significant portions of the actual experience. The boundary between remembering a scent and actually smelling it becomes surprisingly blurred. Memory isn't passive storage and retrieval. It's active reconstruction using the same neural machinery that processes real-world sensation. Fact 46. Visualizing brightness can trigger subtle pupil responses. Pupils constrict when exposed to bright light and dilate in darkness through reflexive mechanisms. Remarkably, in some individuals, simply vividly imagining an intensely bright scene can produce measurable pupil constriction, as if the eyes are physically preparing for light that isn't actually present. The effect is typically subtle and varies considerably between individuals, based on imagery, vividness, and neural connectivity patterns. But its very existence suggests that mental imagery can reach into supposedly automatic, reflexive control systems. The brain isn't only passively describing light mentally when you visualize, it's actively simulating the expected physiological consequences and beginning to prepare appropriate responses. This fits beautifully with the broader understanding that imagination, fundamentally, uses a real sensory machinery rather than occurring in some separate abstract space. When you mentally picture something vividly, the brain partially activates the same networks it would engage for actual perception. That's precisely why visualization can feel so intense and compelling to skilled practitioners. The body responds to imagined scenarios as if they're approaching actual reality, automatically preparing systems in advance based on what the mind predicts. Imagination isn't pretending, it's neural preparation and simulation. Fact 47. Nasal breathing during exercise can improve efficiency over time. Many elite athletes train breathing technique as deliberately and systematically as they train movement patterns and muscle strength. Breathing exclusively through the nose during exercise adds noticeable resistance and naturally encourages slower, deeper breaths compared to unrestricted mouth breathing. This nasal breathing can help maintain steadier, more optimal carbon dioxide levels in the bloodstream, potentially reducing the uncomfortable sensation of breathlessness at any given effort level. The nose also naturally filters particulates, warms incoming air, and adds humidity, which can be particularly beneficial in cold or very dry environmental conditions. Some structured training approaches deliberately use nasal breathing to naturally limit exercise intensity, effectively preventing athletes from pushing too hard too early in training sessions. The breathing constraint forces maintenance of a more sustainable aerobic pace. Over consistent time, this systematic practice can measurably improve overall respiratory efficiency and endurance capacity. It's absolutely not a replacement for actual physical conditioning and progressive overload, but it's a valuable technique that beneficially shapes underlying physiology. Breath control becomes a legitimate training tool that influences performance through altered blood chemistry and intelligent pacing. A small change at the entrance of the airway can ripple outward into heart rate patterns, focus quality, and perceived exertion levels. Fact 48. Breath training can raise tolerance to carbon dioxide buildup. The powerful urge to breathe is driven primarily by rising carbon dioxide levels in your blood, not by lack of oxygen as most people intuitively assume. Systematic breath training can gradually increase physiological tolerance to CO2 accumulation, making that urgent breathing drive less intense and alarming. Practices involving controlled breath holds, carefully paced breathing patterns, or extended exhalations systematically teach the brain through repeated safe exposure that elevated CO2 can be tolerated without danger. The alarm threshold gradually shifts upward with consistent, patient practice over weeks and months. This training principle appears prominently in freediving preparation, classical singing pedagogy, and some evidence-based anxiety treatments. The practical benefit is reduced panic and discomfort around breathing sensations. When the desperate urge to gasp becomes less urgent and overwhelming, you can remain calm substantially longer. Importantly, you're not primarily training lung capacity or chest muscle strength. You're training interpretation and alarm thresholds. The body still carefully monitors carbon dioxide levels, but the brain's emotional and behavioral response to that chemical signal becomes measurably less alarmed and reactive. This creates more breathing comfort under physical and psychological stress, reducing the feedback loop where breathing panic creates more breathing difficulty. Fact 49. Cold exposure feels less intense when attention is skillfully directed. Initial cold water exposure typically triggers gasping, whole body tensing, and strong, subjective discomfort that feels overwhelming. Yet people who consistently train in cold water often describe a fundamentally different experience over time. Not because the water temperature changed, but because their psychological relationship to the sensation transformed. Attention can be deliberately guided towards steady breathing maintenance, intentional muscle relaxation, or curious observation of sensation boundaries, rather than engaging catastrophic narratives about suffering and danger. This systematic attentional shift alters the emotional interpretation layer of cold, substantially reducing perceived intensity. The brain gradually learns through repeated safe exposure that cold doesn't automatically signal mortal danger. The protective alarm response progressively quiets when accumulated experience repeatedly demonstrates safety and survival. Some adaptation is genuinely physiological, but substantial portions represent perceptual retraining. This matters profoundly because emotional distress dramatically amplifies raw sensation intensity. Reduce the panic and catastrophizing layer, and the underlying physical sensation often feels considerably more tolerable and manageable. Attention isn't passive observation of fixed reality. It's an active tool that fundamentally shapes what the body feels like from the inside. Where you place focus and how you interpret sensation creates your actual lived experience. Fact 50. Purpose and meaning can lower perceived effort during challenges, during difficult physical or mental tasks. Requiring sustained effort, the brain constantly evaluates whether continuing is worthwhile and sustainable. Clear, meaningful purpose can substantially change that ongoing cost-benefit calculation. Athletes consistently report that identical physical effort feels subjectively lighter and more sustainable when tied to meaningful goals, such as finishing for a beloved teammate or achieving a deeply significant personal milestone. Research studies suggest that sense of purpose can measurably alter how effort signals are neurologically processed, reducing perceived strain at identical absolute workload. The body performs precisely the same physical work, expending the same calories, and recruiting the same muscle fibers. Yet the subjective experience differs dramatically. Purpose provides compelling justification for tolerating discomfort, which prevents the brain from unnecessarily escalating alarm signals. Meaning functions as a buffer between raw sensation and emotional suffering. When you clearly know why you're enduring something difficult, the nervous system seems more willing to permit the discomfort without interpreting it as emergency requiring immediate cessation. This isn't mystical or metaphorical. It's measurable changes in how the brain processes and responds to fatigue signals. Purpose changes the story, and the story changes the body's willingness to continue. Fact 51. Dramatic treatment rituals can strengthen placebo responses when medical treatment involves elaborate procedures, sophisticated equipment, impressive ceremony, or complex protocols. Placebo responses frequently strengthen considerably. The brain interprets visible complexity and obvious effort as indicators of power and effectiveness, substantially raising expectations about outcomes. This absolutely doesn't mean deception is therapeutically beneficial or ethically acceptable, but it reveals something profound about how context fundamentally shapes treatment outcomes. A confident, detailed explanation, careful preparation rituals, visible effort, and sophisticated appearing tools can all powerfully signal to the nervous system that significant, effective help is arriving. The body may begin shifting into repair and recovery mode before any active pharmaceutical or physical treatment even begins, based purely on these contextual cues and the meaning they carry. The ritual and ceremony surrounding treatment become inseparable parts of the medicine itself, not mere decoration. Understanding this mechanism has genuine practical, clinical value. Clear, confident communication, thoughtful, procedural design, and authentic care can all measurably amplify treatment effects through their direct influence on expectation and trust. The healing environment you deliberately create around interventions becomes therapeutically active. This isn't manipulation or theatrics. It's recognizing that healing occurs in context, and context powerfully matters. Sterile explanation delivered dismissively produces different outcomes than the identical information delivered with warmth, confidence, and evident concern. The medicine and the meaning combine inseparably to create the total effect. Ritual is medicine when it signals safety and competence. Fact 52. Clinician confidence can improve outcomes through expectation alone when a healthcare provider communicates with steady confidence, clear explanations, and evident competence. Patients often experience measurably better outcomes, even before specific treatments have had time to produce biological effects. This communicated confidence provides a powerful safety signal that the nervous system immediately responds to. The brain interprets calm certainty as compelling evidence that threat is manageable and that effective help is genuinely available, which can substantially reduce stress responses that otherwise amplify symptoms and suffering. Provider confidence also fundamentally shapes patient expectation. When you genuinely trust that a clear, effective path forward exists, Attention naturally shifts from desperately scanning for disaster toward noticing signs of improvement and progress. That attentional shift can become genuinely self-fulfilling as the nervous system relaxes its defensive stance. This isn't about false reassurance, minimizing genuine problems, or pretending everything is simple when it's not. It's about recognizing that trust and clarity are active, potent ingredients in healing processes. A calm, knowledgeable presence can measurably change physiology before any medication enters the bloodstream or any procedure begins. Healthcare is fundamentally a human relationship, not merely technical intervention. The quality of that relationship, the trust it generates, and the expectations it shapes all become part of what heals. Competence communicated becomes competence received, changing biology through the pathway of belief. Fact 53. Open-label placebos can work even when you know they're inactive. This seems paradoxical and almost impossible at first consideration. Some carefully designed studies demonstrate that placebo pills can produce beneficial effects, even when people are explicitly told they contain absolutely no active pharmaceutical ingredients whatsoever. The key to understanding this counterintuitive phenomenon lies in conditioning and learned associations. Your body has spent an entire lifetime powerfully associating treatment rituals with relief and improvement. Swallowing pills, following protocols, engaging with healthcare systems. These have become deeply conditioned cues that can shift nervous system state almost automatically. Open-label placebo studies also typically frame participation as an active, collaborative experiment that the person is consciously choosing to engage with, which can restore valuable sense of agency. That restored sense of control matters tremendously because helplessness reliably amplifies suffering across virtually all conditions. This approach absolutely doesn't replace genuine, evidence-based medical treatment for serious conditions, but it demonstrates something genuinely remarkable about human biology. Healing responses can be conditioned similarly to reflexes. The body can respond to familiar patterns even when conscious intellectual awareness fully knows the mechanistic explanation. Honesty doesn't automatically eliminate conditioned physiological effects. The ritual carries power independent of belief in its chemical content. Fact 54. Threatening language can intensify pain more than neutral words. The specific words used to describe upcoming sensations can substantially alter the actual experience. Warning someone that a procedure will sting sharply versus describing it as briefly uncomfortable produces measurably different pain intensity reports. For physically identical stimuli, threatening language primes the entire nervous system for danger and harm. Muscles throughout the body tighten protectively. Attention narrows intensely toward the threatened body area, and alarm systems activate before the sensation even arrives. The brain then interprets incoming sensory signals through that lens of primed threat expectation. Coma, more neutral language, substantially reduces this preparatory alarm response. The identical physical stimulus feels less intense when the prediction framing it is less catastrophic and threatening. This isn't about hiding truth, providing false information, or minimizing genuine risks. It's about carefully avoiding unnecessarily frightening phrasing that adds layers of alarm to otherwise accurate information. Pain is fundamentally partly interpretation, and interpretation is powerfully shaped by the specific words used to forecast what's approaching. Healthcare providers are increasingly trained in this principle. The goal is honest communication that informs without terrifying, preparing people realistically without activating maximum threat responses that amplify suffering unnecessarily. Words are interventions. They change neurology and experience. Fact 55. Suggestion alone can create itch without any irritant present. Itch evolved as a protective mechanism designed to alert you rapidly to potential parasites, irritants, or harmful substances on your skin. This protective function makes the detection system highly responsive to suggestion and expectation. Simply hearing vivid descriptions of crawling sensations, discussing skin irritation in detail, or even reading about parasites can trigger genuine itching sensations in many susceptible people. The brain, primed and vigilant to detect potential threats, begins generating protective sensation based purely on the suggested possibility. Once scratching behavior begins, skin sensitivity actually increases in the affected area, creating a self-reinforcing feedback loop where the behavior itself reinforces and amplifies the sensation. This explains why ichi can become remarkably persistent in conditions significantly driven by anxiety and focused attention. The hopeful therapeutic implication is that attention training and interpretation modification can also quiet itch effectively. When the threat narrative consciously relaxes and attention deliberately broadens beyond body monitoring, intensity often naturally diminishes substantially, even without any changes to the actual skin condition. The mind can create itch through expectation, and the mind can help resolve it through shifted attention. The sensation feels completely physical and real, because it is physically real. But its trigger and maintenance can be substantially psychological. Fact 56. Watching someone scratch can trigger itching in observers. Itch demonstrates remarkable social contagion that's difficult to resist consciously. Seeing someone scratch vigorously can activate strikingly similar sensations in your own body, even when your skin was completely comfortable mere moments before. This likely involves mirror neuron systems throughout the brain that automatically simulate others' actions and potentially their sensations. There may also be evolutionary protective logic. If someone nearby is reacting to irritants or parasites, you might face identical threats in the shared environment. Focused attention dramatically amplifies the effect. Once you notice a particular body area and begin monitoring it carefully, sensation naturally becomes more prominent and insistent. This is precisely why conversations about lice, bedbugs, or mosquitoes can make entire groups squirm uncomfortably. The sensation is completely genuine, not voluntarily imagined or consciously chosen. You're running an ancient prediction and protection system that sometimes generates false positives. What you observe externally in others can become something you physically feel internally in your own body. This demonstrates how permeable the boundary between self and other actually is. At the level of nervous system activation, Fact 57, witnessing injury can trigger nausea through body map activation. Some people feel dizzy, nauseous, or even faint when seeing blood, injuries, or medical procedures. This response can arrive almost instantly, long before conscious thought has adequate time to form a deliberate reaction. The brain maintains detailed internal maps of the body that help you understand, predict, and simulate physical sensations. When witnessing injury to another person, these internal maps can activate intensely as if the observed threat is directly affecting you. In particularly sensitive individuals, this activation triggers a vasovagal response. Sudden, dramatic drops in heart rate and blood pressure that can cause overwhelming nausea, profuse sweating, or complete fainting. It's a protective reflex that would minimize blood loss if you were actually injured yourself. Empathy and emotional connection may significantly contribute as well. Since the brain attempts to simulate and understand what the injured person might be experiencing, the response is trainable through gradual, controlled exposure over time, proving that the pattern can be systematically recalibrated. This isn't weakness or oversensitivity. It's a nervous system running protective simulations so vividly that they produce real physical responses. Fact 58. Touch can gate pain signals. At the spinal cord level, when you accidentally bump your elbow, your hand instinctively and immediately moves to rub the affected area. This isn't merely comfort-seeking behavior or distraction. It's activating a real, measurable neurological mechanism called gate control theory. Touch signals travel rapidly through large, fast nerve fibers. Pain signals travel more slowly through smaller, thinner fibers. At the spinal cord level, increased touch input can effectively reduce how much pain information successfully reaches the brain for conscious processing. Rubbing also naturally brings movement, increased blood flow, warmth, and focused attention, which can reduce fear and protective muscle guarding around the injured area. Fear matters tremendously because worry and anxiety significantly amplify pain sensitivity. Children demonstrate this principle beautifully and instinctively. A comforting hand and gentle rubbing can completely change their entire reaction within seconds. The identical mechanism operates fully in adults, though we often ignore or suppress the instinct. Touch becomes a practical tool for actively reshaping sensation through competing, contradictory input that crowds out pain signals. Fact 59. Chronic stress can delay wound healing through immune changes. Healing requires extraordinarily coordinated immune activity and cellular repair processes. Chronic, unrelenting stress can substantially disrupt this delicate coordination through sustained elevation of stress hormones that alter immune signaling patterns. Research studies have carefully documented slower healing rates of standardized small wounds in people experiencing high ongoing stress compared to calmer control groups. Sleep disruption significantly compounds the problem, as does poor nutrition, both extremely common during prolonged stress periods. The body appears to automatically prioritize immediate survival over maintenance and repair when threat feels constant and unending. This makes excellent evolutionary sense for acute danger lasting hours or days, but becomes genuinely counterproductive when stress never fully resolves. The encouraging aspect is that safety signals, adequate restorative rest, and genuine social support can help restore more normal healing time. The immune system continuously listens to nervous system signals, and calmer inputs support better repair processes. Healing isn't purely biological, it's biopsychosocial, occurring in contexts that includes emotional state, social support, and perceived safety. Fact 60. Optimistic expectations correlate with better surgical recovery. Optimism isn't magical thinking or denial of difficulty, but it can genuinely influence recovery trajectories through both behavioral and physiological pathways working together synergistically. People genuinely expecting positive outcomes tend to engage more actively and consistently with rehabilitation protocols, practice prescribed exercises more diligently, and notice signs of progress rather than only scanning anxiously for problems. This behavioral difference alone changes actual measurable outcomes. Optimism can also substantially reduce rumination and chronic stress responses that might otherwise interfere with sleep quality and appetite. Better rest and steadier nutrition support healing across virtually all body systems simultaneously. Some research studies have linked hopeful outlook with improved recovery metrics after certain surgical procedures, though results understandably vary considerably by specific condition and individual circumstances. The mechanism appears to involve mindset shaping behavior, and behavior directly shaping biological recovery. This isn't about blaming anyone who struggles with hope during difficulty. It's recognizing that outlook can be one modifiable lever among many that influences trajectory. Small shifts in expectation can cascade into meaningful differences in engagement, which cascades into differences in outcome. Hope matters biologically. Fact 61. Adrenaline can temporarily enhance strength and pain tolerance during genuine emergencies. Adrenaline floods massively through your system and temporarily unlocks physical capabilities that can feel almost superhuman. Heart rate surges dramatically, airways open maximally wide, and stored fuel is rapidly mobilized and released into the bloodstream. Blood flow redirects powerfully toward large skeletal muscles, while simultaneously reducing flow to digestive organs and other non-essential systems. Pain perception can decrease dramatically because immediate survival demands unrestricted movement far more than comfort or caution in that critical moment. This explains why people sometimes perform remarkable feats of strength or sprint effectively on significant injuries they do not even consciously notice yet. The dramatic effect is necessarily brief and comes with substantial costs. Hands shake noticeably, digestion completely halts, fine motor control deteriorates, and profound exhaustion typically follows once the perceived danger finally passes. But in the absolutely critical survival moment, the body can access reserves and capabilities that aren't remotely available during normal conditions. The remarkable aspect is how a thought or perception of threat can instantaneously call up such powerful chemical support. Your conscious mind holds the key that releases these emergency reserves, fundamentally reshaping what your body can immediately accomplish. This isn't sustainable or healthy chronically, but it demonstrates the extraordinary range of states your body can access. The same physiology that feels weak and tired one moment can become dramatically capable the next moment, all triggered by perceived urgency. Fact 62. Social evaluation can dry your mouth by shifting autonomic balance. The precise moment you feel watched, judged, or evaluated by others, bodily priorities shift dramatically and automatically. Saliva production decreases substantially because digestive processes become much lower priority than threat preparation and defensive readiness. The mouth becomes noticeably dry and uncomfortably sticky. Swallowing feels frequent, awkward, and incomplete. Speech can suddenly feel clumsy and difficult to control. This is an automatic protective program that evolved for physical danger, now inappropriately triggered by social pressure and evaluation. Stage fright also simultaneously tightens throat muscles, which can noticeably alter voice quality, pitch control, and breathing support. Many experienced performers learn specific techniques to counteract this. Strategic hydration, systematic vocal warm-ups, and breathing practices that actively signal safety to the nervous system. The striking aspect is how rapidly social pressure becomes measurable biology. A room full of watching eyes can reach directly into your salivary glands and change their output within mere moments, all through nervous system signaling activated purely by perceived social threat. This demonstrates that social and physical threats use overlapping neural pathways. Your body doesn't distinguish well between facing a predator and facing a critical audience. Fact 63. Paced breathing can guide heart rate toward slower rhythms. Your heartbeat isn't constant or mechanical. It naturally varies slightly with each breath cycle, typically speeding marginally during inhalation and slowing during exhalation through a phenomenon called respiratory sinus arrhythmia. Paced breathing deliberately elongates the exhale phase while maintaining steady, predictable rhythm, strategically taking advantage of this natural breath-heart relationship. Over several minutes of consistent practice, many people can measurably lower their resting heart rate during the session. This valuable skill appears prominently in diverse training contexts. Marksmen studying their aim before firing, professional singers managing performance anxiety, endurance athletes seeking faster recovery between intense efforts. The beautiful aspect is how mechanical and reliable it is. You don't need to force calm thoughts first or convince yourself to relax. You simply begin with deliberate breath timing, and the body automatically responds by adjusting cardiac rhythms to match the steadier pace you're consciously providing. Self-regulation can be trained through rhythm. Your pulse can be guided like a pendulum when you provide a consistent pattern to follow. This gives you direct, immediate influence over a system that feels completely automatic. Fact 64. Some people can trigger goosebumps voluntarily through attention goosebumps. Typically occur automatically during cold exposure or strong emotional experiences, when tiny erector pili muscles at hair follicle bases contract. The vast majority of people cannot consciously control this process, yet a small minority consistently report being able to trigger goosebumps deliberately through focused attention and intention, often beginning in the back of the neck or forearms, then potentially spreading outward. This rare ability suggests that focused attention can sometimes access the autonomic nervous system, functions usually considered completely automatic and involuntary. The precise mechanism remains unclear and understudied, but it hints at hidden flexibility in mind-body control. It serves as a reminder that the boundary between voluntary and involuntary functions is unperfectly fixed or absolute. For some nervous systems, focused intention can apparently flip switches most bodies keep entirely automated. Not everyone possesses this ability, and it's unclear whether it can be trained or only discovered, but its existence challenges assumptions about what's controllable. If some people can voluntarily trigger goosebumps, what other supposedly automatic functions might be accessible to conscious influence with proper training? The map of voluntary control may have unexplored territories. Fact 65. Yoga practice can improve balance by refining sensory integration. Balance emerges from continuous, dynamic negotiation between multiple sensory systems. The inner ear reporting motion and orientation, visual input reporting horizon and reference points, and proprioceptive signals from muscles and joints reporting body position. Yoga systematically challenges this integration through sustained poses requiring careful weight distribution, controlled transitions between positions, and coordinated head movements that test vestibular stability. Poses demanding sustained single-leg standing force, constant sensory updates about posture and center of mass. The brain learns to combine these multiple sensory streams more efficiently and accurately through repeated practice. Steady breathing adds another valuable dimension, reducing sudden body tension that would otherwise destabilize posture unpredictably. Strengthening small stabilizer muscles throughout feet, hips, and core gives the nervous system a more reliable physical platform to work from. Over consistent time, practitioners often become noticeably steadier not only during yoga practice but in daily activities, like walking uneven surfaces or turning quickly. The brain has updated its ability to coordinate sensory inputs and maintain equilibrium across various unpredictable conditions. Balance training isn't only about strength, it's about recalibration and better sensory fusion. The nervous system updates its internal estimates of where you are in space. Fact 66. Tai Chi reduces fall risk by sharpening proprioceptive awareness. Tai Chi movements appear slow, gentle, and almost meditative, yet they demand extraordinary attention to subtle weight distribution, precise joint positioning, and continuous shifts in center of mass. This builds proprioception, the crucial sense of where your body parts are positioned in space without needing to look at them. The brain learns to track position more accurately and respond smoothly when balance is unexpectedly challenged. The practice also trains relaxed adaptability rather than rigid stiffness. Instead of tensing and freezing when slightly off balance, you learn to yield and adjust fluidly, which reduces the jerky movements that increase fall risk. Research has consistently linked regular Tai Chi practice with fewer falls in older adult populations. The mechanism appears to involve better internal mapping and smoother neuromuscular coordination, demonstrating that preventing falls is about perceptual refinement and responsiveness, not merely leg strength. The movements look simple externally but are cognitively and neurologically demanding. You're teaching your brain a better map of your body in space, and a clearer, more accurate map supports safer movement. Fact 67. Skilled practice can expand brain representation of trained body parts. Your brain dedicates varying amounts of processing space to different body areas based on how precisely and frequently they need to be controlled. These cortical maps can change substantially with intensive practice. Skilled violinists show measurably enlarged cortical representations for fingers of their left hand, which performs rapid, precise placements that must land exactly right. The brain has allocated more detailed territory to support that demanding, critical task. This isn't innate talent or genetic advantage. It's neuroplastic adaptation to intensive, repeated training over thousands of hours. Repeated precise use tells the brain that detailed information from those specific fingers matters critically for survival of the valued skill. Sensation can become more refined as the cortical map expands. Touch discrimination improves measurably. The fingers essentially become more intelligent and capable through the brain's increased attention to signals from them. This also explains why early training often matters significantly, since developing brains may reshape more readily and dramatically, but adult brains retain substantial plasticity. It's never too late to begin changing your cortical maps. Practice doesn't just improve performance, it physically rewrites your brain's representation of your body. Fact 68. London taxi training enlarges hippocampal regions, supporting navigation. London taxi drivers must memorize an extraordinarily complex network of thousands of streets, landmarks, and optimal routes. Through years of intensive study, this mental demand appears to physically reshape specific brain structures. Studies comparing licensed taxi drivers with matched control groups have found measurable differences in hippocampal regions, strongly associated with spatial memory and navigation. The area supporting spatial computation appears structurally larger in those who completed the grueling training. This isn't about general intelligence or overall brain size. It's specific adaptation to specific, sustained cognitive demands. The brain has devoted additional processing power and physical structure to spatial computation because that particular skill was practiced intensively for years. The finding powerfully demonstrates experience-dependent neuroplasticity. Repeated cognitive demands can leave visible structural footprints in brain anatomy that neuroimaging can detect. The city map becomes literally written into neural architecture through years of study and practice. With enough sustained practice, a place outside your body can reshape the physical brain inside your skull. Streets become neural pathways that feel almost instinctive. Fact 69. Learning strengthens white matter connections between brain regions. Learning isn't only about neurons firing in novel patterns or forming new synapses. It also fundamentally involves improving the communication highways that connect different brain areas efficiently. White matter consists largely of myelinated nerve fibers that allow fast, reliable signal transmission across distances within the brain. Training can measurably change white matter properties and pathways relevant to the learned skill. This helps explain why skills become noticeably smoother and more automatic with sustained practice. The brain isn't only storing new, procedural information, it's systematically upgrading the infrastructure that coordinates different regions during skilled performance. Whether learning language, mastering musical instruments, or practicing complex motor skills, consistent practice can enhance the speed and efficiency of neural communication along relevant pathways. Your thoughts literally travel faster along pathways you use most frequently. This represents a deeper level of learning than just forming new connections. It's optimizing existing connections for speed and reliability, like upgrading from dirt roads to highways. Practice changes the speed of thought itself. Fact 70. Habit formation relies on routine reward loops. Not willpower habits operate through elegantly simple scripts triggered automatically by environmental or temporal cues. A cue appears, you perform the routine almost unconsciously, and a reward follows, creating a self-reinforcing loop. This explains why you might automatically reach for a snack when sitting in a certain comfortable chair, even when you're not remotely hungry. The cue chair in context has become powerfully linked with the routine snacking through repeated reward. Changing habits often works substantially better by modifying cues or changing rewards rather than trying to suppress routines through sheer willpower alone. If the brain still predicts reward from the old behavior, it will persistently suggest the behavior. Habits feel automatic precisely because they are automatic. They're learned patterns running efficiently below conscious deliberation, conserving mental energy for novel situations. Understanding the loop structure allows you to work strategically with the machinery rather than fighting it. You can't simply will habits away, but you can systematically reprogram them by changing their components. Habits are neural efficiency, not moral failure. Fatos 61 menos 70 completos, cada con 250 palabras. Próximos 10 71 menos 80. Vamos la 8 de Jan. Fact 71. New routines gradually weaken old habit pathways through disuse. Old habits don't disappear instantly or get erased like deleted files. Their neural pathways remain available and functional, which is precisely why relapse can happen so easily during stress, distraction, or moments of reduced But each time you successfully perform a new routine instead of the old one, you actively strengthen that alternative pathway while the old one simultaneously receives less reinforcement and activation. Over time, with consistent repetition, the new pattern gradually becomes more automatic and accessible. Consistency matters dramatically more than intensity for this rewiring process. Boring, undramatic repetition during calm conditions steadily builds the new default pathway. The old route is still there, like an overgrown trail in the forest, but it's no longer the brain's first automatic choice. Some therapists strategically suggest making the new behavior easier and more convenient than the old one initially, reducing friction so the brain chooses it without internal argument or struggle. This allows the new pattern to establish itself before adding complexity. Change becomes practice rather than constant battle. You're not fighting the old habit directly, you're simply walking a different path repeatedly until it becomes the well-worn default. The old path remains visible, but becomes gradually less traveled, less maintained, and less automatic. Neural patterns follow use. What you practice grows stronger, and what you neglect grows weaker, though it rarely disappears completely. Fact 72. Implementation intentions. Improve follow-through. More than motivation. Motivation is fundamentally an unreliable emotional state that fluctuates constantly based on mood, energy, and circumstances. Implementation intentions are concrete, specific if-then plans that remove decision-making at crucial moments. Instead of vaguely stating, "I'll exercise more," you create a precise plan. If it's Monday at 7 a.m., I will walk for 20 minutes. The specific cue automatically triggers the predetermined behavior without requiring a fresh decision or internal negotiation. This dramatically reduces decision fatigue and removes opportunities for rationalization or excuse-making. At the critical moment, when the specified moment arrives, the script is already written and rehearsed. Research studies consistently show substantially improved follow-through across many behavioral domains. When people create specific implementation plans, compared to relying on motivation alone, the simple structure guides behavior more reliably than desire. Future behavior becomes choreographed rather than improvised. You've already decided what you'll do when the cue appears, so execution becomes nearly automatic. The mental effort happens once during planning rather than repeatedly at each decision point. This transforms abstract goals into concrete triggers and actions. The if-then structure hijacks the same coroutine mechanism that habits use, but deliberately and consciously. Planning beats hoping. Fact 73. Posture can influence confidence through muscle-to-brain feedback. Your body position sends continuous feedback signals to your brain about what state you're currently in. Standing tall with open chest and relaxed shoulders can be interpreted neurologically as readiness, confidence, and capability. When you habitually hunch inward with collapsed posture, rounded shoulders, and downward gaze, the brain may interpret that configuration as defeat, threat, or submission, which can actually influence mood and willingness to engage. This isn't definitive mind control or a cure for genuine confidence issues, but many people notice that deliberately adjusting posture changes how they feel in subtle but meaningful ways. Breathing becomes noticeably easier in open postures, which supports calmer physiological states. Changing posture can also interrupt rumination cycles by physically shifting the body out of a protective curl that reinforces worried thinking patterns. It's a small physical lever that can nudge mental state. The relationship is bite. Confidence affects posture, but posture also affects confidence through feedback loops. You can intervene at either point to influence the system. This doesn't mean forcing unnaturally rigid positions. It means finding aligned, open postures that feel sustainable and allow easy breathing. Your body position is constantly voting on how you feel. Fact 74. Facial expression can influence emotion through feedback loops. Your face doesn't only express emotion outward to others. It simultaneously sends signals back inward to the brain that can influence emotional experience itself. Smiling activates specific muscles that send feedback patterns associated with positive states. Some research suggests this can slightly lift mood, especially during mild negative states, though results vary considerably by context and individual factors. Conversely, holding a tense frown or clenched jaw can reinforce and intensify negative feelings. The facial tension signals de-stress back to the brain, which may interpret and amplify the emotional state accordingly. This bidirectional wiring means expression can actively shape experience, not just passively reflect it. Small changes in facial muscle tension can produce small but meaningful changes in how emotions feel from the inside. This isn't about forcing fake smiles during genuine suffering, which can backfire. It's about noticing habitual facial tension that amplifies difficulty unnecessarily and learning to release it when appropriate. The face is both output and input. It displays emotion and simultaneously helps create it through feedback. Fact 75. Frowning can intensify negative feelings through the same mechanism. When your brow furrows tightly, jaw clenches hard, and facial muscles hold chronic tension. Those sustained muscular patterns send continuous feedback to the brain consistent with effort, frustration, anger, or distress. That bodily state can make negative emotions feel more convincing, intense, and overwhelming. You might notice this during concentration, when facial tension gradually transforms neutral focus into building irritation without any external cause. Facial tightness also affects breathing patterns, often making breath more shallow, effortful, and restricted. Shallow breathing can raise arousal levels, creating a feedback loop where tension breeds more tension. Learning to notice and consciously release facial tension early can interrupt this escalation before it builds momentum. The underlying problem or challenge hasn't changed, but the body has stopped adding extra alarm signals to the situation. Some therapists teach people to scan for furrowed brows as an early warning sign of building stress. Catching it early prevents a mood from spiraling unnecessarily. This feedback loop also helps explain why arguments escalate. Faces tighten, which tightens feelings, which further tightens faces in a self-reinforcing cycle. Softening the face can be a surprisingly effective way to step out of the loop and interrupt escalation. Fact 76. Breath holding can activate the dive reflex and slow heart rate. Humans share an ancient physiological reflex with aquatic mammals like seals and otters. When you hold your breath, especially with facial cooling, the body can shift into a specialized conservation mode called the mammalian dive reflex. Heart rate often decreases noticeably. Blood flow is strategically prioritized toward the brain and heart while reducing flow to extremities. This evolved to preserve precious oxygen during submersion. Freedivers systematically train this response to remain calm and efficient during extended breath holds underwater. The same reflex can be used clinically to help slow certain problematic, rapid heart rhythms. The fascinating aspect is how quickly physiological priorities shift based on one simple action. You voluntarily stop breathing, and the nervous system immediately begins carefully rationing resources, as if preparing for extended oxygen deprivation. This demonstrates direct voluntary access to supposedly automatic systems. A conscious choice triggers deep, ancient programming that reshapes cardiovascular function within seconds. It also shows the body's remarkable intelligence. It doesn't wait for oxygen to actually run low. It responds predictively to the breath hold itself, preparing in advance. Fact 77. Cold water on the face can rapidly calm elevated heart rate. Splashing cold water on your face, particularly around the eyes, nose, and forehead, can trigger components of the dive reflex even without breath holding. The sudden temperature change activates specific pathways that can rapidly slow heart rate and shift autonomic balance toward parasympathetic dominance. Many people experience surprisingly rapid relief from panic or intense arousal this way. It's not merely distraction or shock. It's a specific, measurable physiological response to facial cooling. The location matters significantly. Temperature changes on other body areas produce much weaker effects. This simple, accessible technique demonstrates how targeted the nervous system can be. A specific intervention in a specific location accesses ancient reflexes that can override runaway arousal within moments. It's particularly valuable during panic attacks when other interventions feel impossible. You don't need to think clearly or remember complex techniques. Just splash cold water on your face. The effectiveness can feel almost magical, but it's pure physiology. You're triggering a hardwired response that evolution built for survival in cold water. This is one reason cold showers are sometimes recommended for anxiety, though full-body cold exposure isn't necessary. The face alone is sufficient. Fact 78. Counting slowly can stabilize speech by providing external rhythm when nervousness makes speech rapid, jumbled, and difficult to control. Slow counting creates an external timekeeper that the brain can synchronize with. This forces natural pauses that give breathing adequate time to catch up and gives language planning systems time to organize upcoming phrases. Stumbling decreases because the next thought has time to form before speech begins. Many public speaking teachers use counting or paced breathing before presentations for exactly this reason. The effect isn't only psychological comfort, it produces actual changes in speech rhythm and physiological arousal. A simple numerical pattern can reach into timing circuits and reorganize motor expression. Speech becomes steadier because the brain has a metronome to follow instead of racing ahead. This works even when counting silently. The internal rhythm provides structure that motor planning can lock onto, preventing the runaway acceleration that anxiety causes. It's mechanical and reliable. You don't need confidence first. You just need rhythm, and the rhythm creates steadier output, which then supports developing confidence. External structure compensates for internal Fact 79. Singing extends exhalation and can improve breathing control. Singing demands sustained, controlled exhalation to support musical phrases. This naturally trains breathing patterns towards slower, more complete cycles with better breath management. The chest and throat also receive gentle vibration during singing, which many people find soothing, grounding, and pleasant. Posture typically improves automatically to support breath, reducing upper chest tension. Choir members often develop highly efficient breathing patterns without explicit technical training, simply through regular practice over time. That skill frequently generalizes beyond singing into daily life. Some pulmonary rehabilitation programs strategically incorporate singing practices to support breath control and confidence, particularly for people with chronic lung conditions. It's not replacing medical treatment, but complementing it. There's also an emotional component. Songs can rapidly shift mood, and mood directly influences breathing patterns. The combination creates multiple beneficial pathways. The wonder is that a human art form doubles effectively as breath training. You sing a phrase, and your lungs gradually learn a calmer, more controlled pattern. Music becomes medicine through the mechanism of breath. Fact 80. The immune system receives constant updates from stress hormones. Your immune cells don't work in biochemical isolation, making independent decisions. They constantly receive chemical updates from the nervous system, including stress hormones like cortisol and adrenaline, in short bursts. This communication can be useful and adaptive. It mobilizes energy and temporarily shifts immune priorities as if injury might be imminent, which makes sense during actual physical threats. When stress becomes chronic and unrelenting, the signaling changes problematically. The message becomes confused and contradictory. Inflammatory signaling can rise or fall at inappropriate times, and the body can become less efficient at fundamental repair processes. Researchers study this bidirectional communication because it explains why psychological stress can influence everything from wound healing speeds to infection susceptibility to autoimmune flare-ups. It also explains why calming routines can feel like medicine. Quality sleep, regular meals, and social safety send different chemical signals to immune cells, allowing them to function more optimally. The mind doesn't directly command every immune decision, but it powerfully shapes the chemical environment those decisions are made within. Your thoughts become chemistry, and chemistry becomes immune behavior. Mental state is biological context. Fact 81. Loneliness can elevate inflammatory markers as if preparing for injury. Loneliness is not merely a subjective feeling or emotional state. It can be interpreted by the brain as a significant risk condition, similar to being isolated without protection in a potentially dangerous environment. When this interpretation occurs, the body may systematically shift toward higher baseline inflammation. Researchers have found consistent associations between chronic social isolation and elevated inflammatory markers in numerous studies, suggesting the immune system may behave as if physical wounds are statistically more likely when you're alone and vulnerable. This pattern makes excellent evolutionary sense. When examined functionally, if you're isolated from your social group, help may be far away or completely unavailable. The body therefore prepares defensively for potential harm by keeping inflammatory defenses constantly ready and activated. The significant problem is that modern loneliness can be chronic, lasting months or years, and chronic inflammation is metabolically costly. It can negatively affect energy levels, sleep quality, pain sensitivity, cardiovascular health, and mood stability. The most striking aspect is how invisible the trigger can be. You can appear outwardly fine while your immune system behaves internally as if it expects imminent trouble and injury. Social connection can powerfully reverse this signaling pattern. A supportive conversation, a shared meal, or genuine sense of belonging can signal safety to the nervous system, reducing the body's perceived need for constant defensive readiness. The immune system stands down when connection communicates that help is available. Fact 82. Compassion practice can reshape brain responses to others' suffering. Compassion is not merely a fixed personality trait you either possess or lack. It can be systematically trained and strengthened like any other skill through deliberate practice over time. In compassion-based meditation practices, people systematically rehearse caring attention and the sincere wish to reduce suffering, typically starting with themselves and gradually expanding outward toward others over weeks and months of consistent practice. Brain imaging studies suggest meaningful changes in how practitioners respond to witnessing distress in others. Some research shows less overwhelming emotional flooding and more regulated, sustainable engagement with suffering. This distinction matters tremendously because empathy without adequate regulation often leads directly to burnout and compassion fatigue. Compassion adds emotional stability and warmth that help you remain present with pain without drowning in it or shutting down defensively. People often report that suffering becomes more understandable and less frightening after sustained practice. You become more likely to help effectively and less likely to avoid or minimize others' pain. There's also a measurable physical dimension. Compassion practice can demonstrably lower stress responses that would otherwise create chest tightness and shallow breathing when encountering suffering. The fascinating idea is that caring can become a trained nervous system state rather than just a moral intention. You're not forcing kindness artificially. You're systematically training a calmer, more open way of meeting pain, and the brain gradually adapts to that training. Fact 83. Gratitude journaling can improve sleep quality in some studies. Many people think sleep is controlled purely by physical factors like circadian rhythms and adenosine buildup. Yet the mind powerfully sets the stage for sleep through what it reviews and rehearses at bedtime. Gratitude journaling works therapeutically by systematically changing what the brain reviews during the vulnerable pre-sleep period. Instead of replaying threats, rehashing conflicts, and cataloging unfinished tasks, you deliberately practice noticing what went well and what felt supportive. That attentional shift can substantially reduce rumination, which is a common and powerful thief of quality sleep. Some research studies have linked regular gratitude practices with better subjective sleep quality and fewer nighttime awakenings. Though results vary between individuals and study designs, the mechanism is highly plausible from a neuroscience perspective. A calmer mind produces lower physiological arousal, and lower arousal directly supports deeper, more restorative rest. Gratitude also systematically changes emotional tone from urgency and threat towards safety and sufficiency. Safety is an extraordinarily powerful sleep signal that tells the nervous system it is appropriate to become vulnerable and unconscious. This isn't about pretending life is perfect or denying genuine difficulties. It's about strategically guiding attention towards stability and support, so the nervous system can appropriately stand down. When the brain stops vigilantly scanning for danger, the body often follows naturally with slower breathing, softer muscles, and easier sleep onset. Fact 84. Mindfulness reduces rumination by loosening attention loops. Rumination is the mind's stubborn habit of chewing the same thought repeatedly until it feels increasingly true, urgent, and inescapable. Mindfulness trains a fundamentally different relationship with thought itself. Instead of unconsciously merging with mental content and believing every thought automatically, you practice deliberately noticing thoughts as temporary mental events that arise and fall away like clouds passing through sky. That subtle shift creates valuable psychological distance between thought and identity. Thoughts become objects you can observe rather than tunnels you must helplessly enter and follow. Over time, with consistent practice, this observational stance can measurably reduce the grip of repetitive thinking, especially during nighttime or high-stress periods. People often describe experiencing more space between triggers and their automatic reactions. That space matters tremendously because it interrupts automatic spirals before they build momentum. Mindfulness also teaches experiencing physical sensations without immediate catastrophic interpretation, which can reduce anxiety-driven body monitoring. The practice is not empty relaxation or forcing the mind blank. It's systematic training in how attention moves and where it habitually gets stuck. Brain imaging studies often find measurable differences in networks involved in self-focused thinking and emotional regulation among long-term practitioners, though individual results vary considerably. The larger insight is elegant. By deliberately practicing where you place attention, you gradually change what your mind automatically repeats, and that fundamentally changes what your body continuously feels. Fact 85. Attention training can lessen tinnitus distress without changing sound. Tinnitus, the perception of sound without any external source, can feel unbearable, primarily because attention becomes completely captured and locked on the internal noise. The sound may remain relatively steady, yet distress escalates when the brain treats it as an urgent threat that must be solved. Attention training approaches aim to fundamentally change that relationship rather than eliminating the sound itself. Instead of desperately fighting the sound or trying to make it disappear, you practice deliberately shifting focus away from it and back again on purpose. This teaches the brain experientially that you have choices and agency. Over sustained time, the sound may still exist objectively, but it gradually moves toward background rather than dominating foreground attention. Some therapeutic approaches use structured exercises that systematically pair relaxation with sound exposure, helping the brain learn safety in its presence rather than constant alarm. This is not pretending the sound is gone or denying its existence. It's changing the meaning and threat value assigned to it. When the sound stops being continuously evaluated as danger, stress responses naturally drop, muscles loosen, sleep often improves, and the sound becomes less intrusive. The fascinating and hopeful point is that suffering is not always directly tied to stimulus intensity. It's often tied more closely to attention capture. When attention becomes flexible and trainable, subjective distress often shrinks substantially, even if the signal itself remains unchanged. Fact 86. Pain catastrophizing predicts suffering better than injury size. Two people can have remarkably similar injuries visible on imaging, yet experience vastly different levels of pain and disability. One major factor consistently predicting this difference is catastrophizing, a pattern of thinking that expects the worst and treats pain as definitive proof of disaster. This mental stance dramatically increases fear and perceived threat, and fear makes the nervous system substantially more protective and defensive. Muscles tighten chronically, attention narrows obsessively toward the body, and the brain amplifies warning signals. Catastrophizing also systematically steals hope and agency, which reduces willingness to move and engage with rehabilitation. It predicts long-term disability and distress across many different conditions more reliably than objective injury measurements. Clinicians increasingly track catastrophizing because it's such a powerful predictor of outcomes. The encouraging news is that it's highly modifiable through intervention, education about pain, science, cognitive therapy approaches, and graded exposure to movement can effectively teach the brain that pain doesn't always equal harm. When catastrophic predictions quiet down, the body often substantially reduces its alarm response. Pain may remain to some degree, but it feels less threatening and overwhelming. This doesn't mean pain is imaginary or exaggerated. It means interpretation powerfully amplifies or dampens the signal. In the realm of mind over matter, the story you tell about pain literally becomes part of the pain itself. Fact 87. Chronic pain can persist after healing due to nervous system sensitization. Sometimes tissue has completely healed. Scar tissue has matured, and imaging shows no ongoing damage. Yet severe pain stubbornly remains. This puzzling situation occurs when the nervous system itself has become sensitized, like a smoke alarm stuck perpetually in the on position. Nerve pathways that were repeatedly activated during initial injury can become hyperresponsive and overreactive, triggering intense pain signals from stimuli that wouldn't normally be remotely painful. The protective system continues protecting against threats that no longer actually exist. Understanding this mechanism completely reframes chronic pain as a nervous system condition rather than ongoing tissue damage. That changed framework fundamentally alters treatment approach toward retraining and updating predictions rather than searching endlessly for structural problems to fix. The brain has essentially learned pain as a pattern, similar to how it learns any other repeated experience. Through that learning, the pain becomes self-sustaining even after the original cause has resolved. The hopeful implication is that learned patterns can theoretically be unlearned through careful retraining. Safety learning, gradual movement exposure, and systematically updated predictions can help reset an overprotective system. It's not quick or simple, but many people find that understanding the mechanism itself reduces fear, which begins the process of calming the system down. Fact 88. Pain pathways can be retrained through graded exposure and safety learning. When chronic pain has become a deeply learned pattern in the nervous system, retraining approaches gradually teach safety through accumulated experience rather than explanation alone. Gentle exposure to previously feared movements, starting well with intolerance and very slowly expanding range, allows the brain to collect new contradictory evidence. The body learns experientially that it can move without catastrophic consequences. This is systematically paired with education about pain neuroscience, helping people intellectually distinguish between sensation and actual harm. Understanding that hurt doesn't automatically equal damage fundamentally changes interpretation. Progress often feels frustratingly slow because old pathways are extremely well established and efficient. The brain defaults to familiar patterns under stress. But many people gradually find that pain flare-ups become less frightening and less frequent as the nervous system learns different response patterns. This isn't positive thinking or willpower. It's systematic retraining based on accumulating safe experiences that contradict old predictions. Each successful movement without disaster is evidence that updates the brain's threat assessment. The approach requires patience, consistency, and often professional guidance, but it offers hope where purely structural medical approaches have failed, because it addresses the actual problem: learned hypersensitivity. Fact 89. Exposure therapy rewires fear through repeated safe encounters. Fear learning happens remarkably quickly. One genuinely bad experience can permanently mark a situation as dangerous in memory. Exposure therapy uses the brain's learning capacity in reverse through gradual, structured contact. By carefully facing feared situations in small, manageable steps while remaining objectively safe, the brain's predictions systematically update. Catastrophe doesn't occur repeatedly. The alarm gradually quiets, incrementally. This isn't flooding someone with overwhelming terror, which can backfire badly. It's careful, titrated training that keeps arousal within a tolerable range where learning can actually occur. The explicit goal is updating predictions through new data, not forcing courage. Exposure works effectively for phobias, panic disorder, and trauma responses, with strong research evidence supporting it. The approach demonstrates that fear is fundamentally a prediction about what will happen, and predictions can be systematically revised through new data gathered in safe conditions. The brain essentially learns, "I thought disaster would happen, but it didn't," over and over until that becomes the new default prediction. The old fear doesn't completely erase, but it loses its automatic grip. This reveals fear as trainable and modifiable rather than permanent and fixed. Fact 90. Runner's high involves both endorphins and endocannabinoids for decades. People spoke about the runner's high as if it were mysterious, mystical, or purely psychological. Today, neuroscience paints a much clearer biochemical picture. Sustained aerobic exercise triggers release of endorphins, which reduce pain perception, combined with endocannabinoids, which can cross the blood-brain barrier and directly influence mood and perception. These chemical systems work synergistically together to create feelings of calm, clarity, mild euphoria, and effortless motion. Unlike the frantic energy of adrenaline, this state feels steady, warm, and peaceful. That's why the effect typically appears after sustained duration rather than at the start of a workout. The brain is biochemically rewarding persistence. Not everyone experiences it identically, and intensity matters less than consistency for accessing the state. The fascinating aspect is that this uplifting neurochemical state is built directly into human biology, accessible through movement. Exercise unlocks chemistry specifically designed to make endurance feel meaningful and rewarding rather than purely punishing. This probably helped our ancestors persist during long hunts or migrations. You're not imagining the shift in consciousness during sustained movement. Real molecules are changing brain function, altering perception and emotion through purely biological mechanisms triggered by choosing to move. Fact 91. Exercise raises brain-derived growth factors supporting neural health. Physical movement sends powerful growth signals cascading throughout the brain, not just the muscles. One key molecule is BDNF, brain-derived neurotrophic factor, which supports neuron health, synaptic communication, and neuroplasticity. When BDNF levels rise through regular exercise, brain cells become measurably more adaptable, resilient, and capable of forming new connections. Many researchers link this process directly to improvements in mood stability, focus, quality, and stress tolerance associated with consistent physical activity. This isn't an instant effect, and it's not guaranteed universally for everyone. But the trend is strong enough across populations to directly inform clinical treatment. Guidelines for depression and anxiety disorders. Exercise also improves cerebral blood flow substantially, delivering oxygen and vital nutrients more efficiently to hungry brain tissue. Together, these changes create a more flexible, adaptive neural environment where thoughts feel less stuck and rigid. Emotions often recover more quickly after stress in people who exercise regularly. The brain becomes more capable of shifting states rather than staying trapped in negative patterns. The profound implication is that moving the body fundamentally changes the brain's growth landscape and chemical environment. Motion becomes a message that says adaptation is needed, and the brain responds by becoming more adaptable at the cellular level. You're not just building muscle or cardiovascular fitness, you're cultivating a more resilient, flexible brain that can better handle life's inevitable challenges and stresses. Fact 92. Natural settings reduce rumination and quiet stress-related brain activity. A walk through trees, parks, or open natural landscapes feels subjectively different from walking down busy urban streets. Brain imaging studies suggest there are real, measurable neurological reasons for this consistent difference. Time spent in natural settings is associated with reduced activity in brain regions, strongly linked to repetitive self-focused thinking and worry. Rumination often keeps stress alive by endlessly replaying concerns without reaching resolution or action. Nature appears to interrupt that unproductive loop effectively. The sensory environment is rich and engaging but not demanding or threatening. Leaves move gently, light shifts subtly, sounds very naturally, giving attention something peaceful to rest on without effort or vigilance. This can meaningfully lower mental noise and allow accumulated emotional tension to gradually ease. Even brief exposures can produce effects, especially when digital devices are intentionally set aside. The benefit doesn't require vigorous exercise since slow walking works. It's fundamentally about context and environmental quality. The brain evolved in natural environments over millions of years, and those ancient cues may signal safety and resource availability rather than urban urgency and threat. A simple walk outdoors can change how thoughts circulate through your mind, turning repetition into release. The nervous system recognizes an ancestral environment and responds by lowering defensive vigilance. Fact 93. Morning sunlight influences serotonin pathways and sets circadian timing. Early daylight exposure is one of the strongest, most reliable signals for regulating your internal biological clock. Light entering the eyes early in the day directly influences serotonin pathways, supporting mood, motivation, and daytime wakefulness. This morning light exposure also helps set sleep timing for later that night by synchronizing circadian rhythms. Without adequate daytime light exposure, alertness can lag noticeably, and mood can suffer significantly. The effect doesn't require staring directly at the sun, which would be dangerous. Simply being outdoors or near bright windows provides sufficient signal strength. For most people's photoreceptors, sunlight also dramatically improves visual contrast and color perception, which keeps the brain engaged and stimulated. The combination of circadian signaling and enhanced perception creates multiple beneficial pathways. The fascinating detail is how indirect and automatic the process feels subjectively. You're not consciously choosing to feel awake or energized. Light enters the visual system and quietly tunes underlying chemistry and biological timing without any deliberate effort. Daylight becomes a guide that keeps brain chemistry and sleep-wake cycles properly aligned with the external world. This alignment supports both energy during the day and quality sleep at night. Modern indoor living disrupts this ancient relationship, contributing to widespread sleep and mood problems. Fact 94. Warm baths support sleep by triggering core temperature drop. Sleep onset is closely tied to decreasing core body temperature through well-established circadian mechanisms. Warm baths can paradoxically accelerate this cooling process through clever physiology. The heat causes peripheral blood vessels throughout the skin to dilate substantially. After exiting the bath, heat dissipates rapidly from the dilated vessels at the skin surface, and core temperature consequently falls more quickly than it would otherwise. This temperature drop sends powerful signals to the brain that night has arrived and sleep is appropriate, often creating a noticeable wave of drowsiness within 60 to 90 minutes. Warm water also relaxes tense muscles throughout the body and naturally slows breathing patterns, further supporting the transition toward rest and recovery. Timing matters significantly for optimal effect. Bathing approximately 1 to 2 hours before desired sleep time works best for most people, allowing time for the cooling process. You're using warmth strategically to encourage cooling, and that cooling invites sleep through ancient biological pathways. A simple sensory experience aligns perfectly with deep physiological rhythms. Many cultures throughout history developed bathing rituals before sleep without understanding the precise physiology. They discovered through experience what science later confirmed through measurement. Fact 95. Rituals reduce anxiety by providing predictable structure. Anxiety thrives primarily on uncertainty and unpredictability. Rituals systematically counter that by creating reliable, repeatable patterns that reduce the brain's need to constantly predict and prepare for threats. When actions follow a familiar, established sequence, decision fatigue decreases substantially and sense of control increases meaningfully. The specific content matters less than the consistency and reliability. Even remarkably small rituals, like preparing tea the same way each evening or following a specific morning routine, can lower background stress levels. The brain learns that this particular pattern reliably leads to safety or successful completion. Rituals also effectively mark transitions between different states or contexts, helping the nervous system shift modes appropriately. The predictable sequence signals what's coming next. In moments of high stress, rituals anchor attention and reduce overwhelming decision overload. They provide structure when everything else feels chaotic. The fascinating aspect is that rituals work even when we consciously know they are symbolic rather than mechanistically necessary. The nervous system responds to structure at a level below conscious belief. Predictability becomes comfort, and comfort reduces anxious arousal. The ritual doesn't need to be elaborate or time-consuming. Simple consistency creates the beneficial effect. Fact 96. Superstitions can boost performance by increasing perceived control. Superstitions often look completely irrational from the outside, yet they persist stubbornly across cultures for clear functional reasons. Believing that a certain action, object, or ritual brings luck can meaningfully increase sense of control in inherently uncertain situations. But enhanced sense of control matters tremendously. It reduces anxiety and frees valuable mental resources for the actual task at hand rather than worrying about outcomes. Studies have demonstrated that people sometimes perform measurably better when they believe a lucky charm is helping them. The charm doesn't change physics or probability, but it changes mindset, confidence, and focus. Confidence rises, hesitation decreases, and effort becomes smoother and more fluid. The key isn't the superstition itself, but what it does to attention and emotional state. When the brain feels supported and protected, It stops vigilantly scanning for potential failure. That freed attention can be directed toward performance instead of worry. The fascinating truth is that belief can function as a genuine performance aid, not by altering external reality, but by altering how fully you engage with the task. You access your actual capabilities more completely when you're not simultaneously fighting doubt. This doesn't validate the superstition's content. It validates the psychological mechanism of enhanced perceived control, reducing interference. Fact 97. Mental scripts can prevent choking under pressure, under intense performance pressure. The conscious mind often interferes destructively with skills that normally run automatically, causing performance collapse called choking. A calm mental script offers an alternative focus that prevents this interference. Instead of thinking about outcome or consciously controlling mechanics, the script guides attention to simple cues like rhythm, breathing, or general intention. This keeps conscious thought engaged without entangling it in processes that work better automatically. Athletes, musicians, and speakers often rehearse these scripts extensively in advance, so they feel completely familiar under stress. The script acts like a track the mind can follow when nerves rise and thinking becomes difficult. Breathing often slows naturally as well, which steadies the body. The power of the script isn't distraction from the task. It's direction of attention toward helpful cues and away from destructive stuff. Attention stays engaged but not interfering. The fascinating part is that a few chosen words or phrases can protect highly complex motor skills from collapse. Language becomes a stabilizing tool that keeps performance aligned with thousands of hours of practice rather than derailed by momentary fear. The script must be practiced until automatic, becoming as rehearsed as the skill itself. Fact 98. Athletes perceive targets as larger when performing well. Confidence subtly alters visual perception in measurable ways. In various studies, athletes performing well report that targets appear larger, closer, or easier to track compared to when they're struggling. This doesn't mean eyes physically change or that objective visual acuity improves. It means the brain's interpretation of visual information shifts systematically with emotional and confidence state. When confidence is high, attention is less cluttered by doubt, worry, and negative perception may consequently feel clearer and more generous. As a result, when confidence drops, the opposite pattern can occur. Targets subjectively feel smaller, margins feel tighter, and everything seems more difficult. The effect highlights how perception is fundamentally shaped by readiness, expectation, and emotional state. Vision is absolutely not just a passive camera feed delivering objective information. It's an active construction influenced by emotion, memory, and confidence level. The fascinating insight is that belief doesn't merely affect effort or motivation. It can actually affect what the world seems to offer before any action begins. Confidence makes opportunity literally look larger and more accessible. This creates potential for intervention. If perception changes with confidence, then building confidence might change perception, which could support better performance in a beneficial cycle. Fact 99. Anxiety can make time feel slower because attention spikes during intensely anxious moments. Seconds can feel stretched, heavy, and agonizingly slow. This happens because attention becomes sharply focused and hypervigilant on the present moment, especially potential threat. When more information is processed per second through heightened attention, subjective time appears to slow down. The brain is sampling the environment extremely intensely, creating a denser, richer memory of the interval. Later, when you recall that period, the density of stored information is interpreted as longer duration. You remember so much detail that it must have lasted a long time, even if objectively it was brief. This effect can be useful in genuine emergencies, where rapid assessment matters critically. In everyday anxiety, though, it makes waiting feel unbearable and discomfort seem endless. When anxiety fades and attention naturally broadens again, time often seems to speed up dramatically. The clock stays constant, but subjective experience doesn't. The fascinating detail is that time perception is remarkably flexible and state-dependent. It bends with emotional state, attention, intensity, and arousal level. By deliberately calming attention through breathing or grounding techniques, people can sometimes ease the sensation of dragged-out moments. The clock stays the same, but the experience changes through altered attention. Fact 100. The brain actively suppresses movement during vivid dreams while you sleep. Especially during REM periods when dreams are most vivid and story-like, your brain becomes extraordinarily active. Stories unfold, emotions rise and fall, An imagined movement can feel completely real and physical. Yet your body usually stays almost completely still throughout. This happens because the brain actively dampens and blocks motor signals sent to the muscles, creating a protective state called rematonia, or sleep paralysis. Without this crucial system functioning properly, people would physically act out dream scenarios, sometimes with dangerous consequences. Rare conditions where the suppression fails can result in sleepers kicking, punching, or even leaping from bed while dreaming. The remarkable part is that paralysis is not passive. It's an active command sent continuously from the brainstem to the spinal cord throughout REM sleep. Your brain knows you're dreaming even if you don't, and it intelligently chooses safety over expression. Each night, consciousness and physical restraint work together quietly and efficiently, allowing imagination to roam completely freely while the body rests safely in place. It's a beautiful example of the brain protecting itself from its own vivid internal experiences. Dreams can be wild adventures precisely because the body is safely immobilized. The mind explores while the body recovers. Conclusion: the profound connection between mind and matter as we gently reach the end of our journey through 100 discoveries about mind over matter. A clear and powerful theme has emerged. Again and again, we've seen that your experience is not simply given to you passively by the external world, but actively constructed through the intricate interplay of sensation, interpretation, expectation, memory, and bodily state. Belief can genuinely ease pain. Fear can physically narrow perception. A single breath can measurably shift your pulse. Even a simple ritual can calm the anxious mind through pure, predictable structure. We explored the body's hidden conversations, from the gut's quiet signals to the way the brain continuously edits sensation into something you can comfortably live inside. We witnessed the remarkable flexibility of the self, where mirrors can ease phantom pain and virtual worlds can soften real suffering by skillfully capturing attention. We listened to the chemistry of movement, where sustained endurance releases relief and clear purpose makes effort feel lighter and more meaningful. We even heard the shared human rhythms, where singing and synchronized breathing can align multiple bodies, as if a group becomes one living, coordinated system of breath and heartbeat. And now, you don't need to hold any of this information tightly. Let it settle gently like snow, soft and quiet. Let your shoulders completely release. Let your jaw soften and relax. Feel gravity helping you sink deeper into rest. If thoughts arrive, let them pass by like distant cars on a highway. Notice briefly, then gone. If you feel your breathing, don't try to change it. Just notice how it happens by itself, wave after wave, completely automatic. If you're still awake and enjoyed this exploration, there may be another video waiting on your screen, but that can wait too. Everything can wait now. For now, there's only this: the gentle dark, the softness of rest, and the quiet truth that your mind and body are far more intimately connected than you ever imagined. Sleep well, friend, and good night.